The event today that we're holding is the PPMA Conference. It's our first one that we've ever run. And the aim of the conference is basically to bring together our big organisations that within our membership, who have these huge departments full of people that understand what regulations and what industry trends are coming the way of our industry. And it's to basically put them in front of our smaller members, who are SMEs, and to give them the information and the knowledge they need to successfully run their businesses moving forward. I think when you run a small business, the things that you don't know are what keeps you awake at night, not the things that you do know and that you can deal with. So by laying on these speakers today, very knowledgeable people talking about things like cybersecurity and hygienic design, they're able to provide the knowledge and the information to our member companies so they can make sure they're compliant moving forward.
We'd like to welcome everybody here today for the inaugural PPMA Conference organised by Automate UK. Really excited to see so many like-minded people in the room. There's some great topics and subjects that are going to be discussed. I'm sure they'll all get a lot of value out of it. And real excited to see the networking that's going on as well. It's great to see so many like-minded people in the room.
Okay, let me give you an order of play of today then. So each speaker is going to have about 30 minutes, and then at the end of that we'll have a roving mic and we can have 15 minutes of questions and answers. That's what we always say is the best part of events like that. That's when it gets exciting, because what's in your mind, you'll be having a question that someone else has also got. So please do speak up. That makes these events even better. It really does. Lunch is going to be your first break, so that will happen from 12 till 1. And then when all of that's finished, you'll come back into here. Then there'll be 2 more speakers, again with the 30-minute, 15-minute timing, and then break will happen. Another break will happen at 2:30. You will then have 1 hour of networking, as we've said a few times this morning already, but that hour as well, the speakers will be in here. They'll have tables, so you can head back in here and just network and have a bit of a tour of the facility. Okay, enough of all of us and housekeeping. Can I please welcome to the stage Greg Harper. He's going to do a talk on, it's an interesting one actually, on hygienic design. Now Greg's OEM integrator background, food industry focus and leadership in eHedge Robotics Hygiene Group make him a key voice in food manufacturing automation, making his insights crucial for anyone navigating the complexities of modern food manufacturing. Please welcome Greg to the stage.
Well, welcome to our first presentation on hygienic design, titled Hygienic Design Who Gives? Not my choice. I'm standing in for someone else who was going to do the presentation originally, my colleague Steve Arnold, who's our US and Europe food safety manager. He's jet setting around the world. He's at a sustainability conference in Germany at the moment. But I'm more than happy to stand in for him because I represent the UK food industry, mainly working with the OEMs, but also liaising with our end user teams. And as Lindsay had mentioned, I've got an OEM background. I started off with a special purpose machinery manufacturer in robotics and automation for a diverse range of industries, then moving on to a line builder and system integrator for the food industry before moving over to SMC last year in this role. What can I tell you about hygienic design that you don't already know? Everything's going to be stainless steel that's fabricated. That's going to be the main part of your machine structure. If it's not stainless steel, it's going to be blue. It's going to be food contact materials. If you're putting electronics on it, you're going to be looking for an IP rating, probably IP67, IP69, because as we all know in the food industry, everything gets covered in water. And if you're buying anything to bolt onto your machines, you're probably looking for FDA compliance as the go-to. But the thing is, hygienic design is expensive. The principles are expensive, the products are expensive. So why bother? Well, I'd like to turn that argument on its head today and show you that hygienic design is not expensive, and actually you can increase your customers' production uptime. Let's start by looking at poor hygienic design. Poor hygienic design is damaging. If you have a food safety, or if your customer has a food safety failure, they're going to be recalling their products. That's going to damage our confidence as consumers. It's going to result in production downtime, and it's going to cost them a lot of money and time whilst they review and inspect what caused the food safety failure. Poor hygiene is dangerous. If there's a food safety failure, we're looking at pathogens. In poor hygiene design, allergens are not going to be properly cleaned out of the equipment, which means that people could have an allergic reaction to contaminated food. Pathogens and contamination isn't going to be easy to clean out of the machines either. That's dangerous to our health as consumers, and potentially it's dangerous to life, as you may have seen in the news recently with the listeria outbreak linked to hospital food, hospital-served food. And we'll go into a bit more detail of that shortly. And finally, it's expensive. Poor hygienic design is expensive. It's going to take more time for your end user to clean their machinery lines. It's going to cost them more money on materials and cleaning agents, water, energy, maybe more people to clean the lines down. And if the equipment hasn't been designed in a good hygienic manner, it may even be that you're called in to make modifications, changing materials, making the design better so that the water and the cleaning agents drain away properly. £8 million. That's the average cost of direct and brand damage to an end user if there's a food safety failure. What do we think the highest UK food safety fine is? Any guesses?
20 million.
20 million? It's just under 8 million. It's still a big number. It's still a very big number. That was served to Tesco's for out-of-date food safety offences some years back. If you recall, Kinder Bueno had an outbreak of salmonella not so long back in 22. How many cases were reported worldwide for that? More than 400. And how long do you think their production line was down while they inspected and looked into what the cause of that was? 2 months? Keep going? Sorry? Keep going? 9 months. 9 months of production stoppage whilst they investigated the cause of that and were approved to restart the production. And when Cadbury's had their salmonella outbreak in 2006, I'm not used to having a camera watching me. In 2006, that cost them £20 million to recall 1 million products. So looking at this recent outbreak of listeria in the hospital, there is currently a joint investigation going on into that outbreak. So far, there have been 5 people linked to that. 3 have unfortunately died, and 2 who also died, the cause of death has been linked back to that listeria, but it's not necessarily the primary cause of death. The Food Standards Agency, UK Health and Security, etc., are all involved in this investigation into that food safety failure. Listeria was found in chocolate and vanilla mousse with strawberry. Now, if you remember, I just mentioned about cleaning equipment down properly and the potential for cross-contamination. So from the outset, if we're looking at what's happening here, recalling a product that's not necessarily got all the same ingredients, potentially there's a hygiene issue there where equipment hasn't been properly cleaned down, meaning the pathogens have remained and there's potential cross-contamination of ingredients. And that could have been an allergen ingredient, so that could have been even more serious, affecting even more people, not to take the seriousness away from the 5 that have been affected so far. All of those desserts that are potentially linked to that food safety failure are being taken out of the supply chain as a precaution. So they put in a food alert action to protect vulnerable customers. So of course, people that are in hospital, they're very vulnerable at the moment because they're suffering an illness, they're going through recovery, so they're particularly vulnerable to any food that has got any contamination, any issues. Generally, listeria is only going to cause mild illness, but there is potential that it will affect those that are vulnerable more seriously, as we've seen. Some of you might have seen this diagram before. It's often referred to as the sinner's circle, but let's look at it today in the sense of good hygienic design. On the left-hand side, we'll see cleaning agents and temperature, and if we think about good hygienic design, then potentially you're going to reduce the amount of chemicals and water that are used to clean equipment, and maybe even the temperature used to clean the equipment down. And that's going to save your customer time and money, and it's going to be more sustainable for the environment. On the right-hand side in blue, mechanics and time. If the equipment's easier to clean and has less build-up of contamination, it's going to be easier to clean it. And again, it's going to take less time to clean it down. And it's generally considered across the food industry that 20 to 30% of all production time is given over to cleaning. So that's where your savings are and potential gains, and when you put machines in that are well designed to increase their production uptime. does hygienic design actually look like then? The general considerations are, is the equipment easy to clean? And are the materials used in the design of that machine and in contact with the food safe to consumer health? And we can break this down into 3 zones. The first and most critical zone being the food contact zone, and this is designed for direct contact with the food and the handling of the food, including surfaces that food may come into contact with and then go back into the food product food stream. Secondly, the splash zone. So this is an area where food may be exposed from the process, splashing onto surfaces, but the food in this area is not designed for consumption. And finally, the third area is the non-food zone, which can be expected to be exposed to minor dirt and debris and build-up, but no food contact is intended for that area. So these will be all the areas of outside and underneath your machine, typically. How many of you have heard of the European Hygienic and Engineering Design Group? I'm not surprised at that answer, that's okay. It's a fantastic organisation, it's a member organisation. They've been around for 30 years, but they're really starting to ramp up their presence now. And I'm actually, as Lindsay had mentioned, I'm in one of the working groups there. So it's a members organisation, originally set up by Unilever, involves a lot of the big names in the global food industry. There are working groups in there that put together best practice guidelines according to certain applications, certain products. So there's one for chocolate, there's one for conveyors, and it's ever growing. And I sit on the robotics working group, so we're looking at putting a guideline together at how robotics are used in the open food processing environment in a hygienic way. We're going to look at some examples now of the hygienic design principles, and I've just put this legend table up before we start. So you'll see that blue is for product and product area, orange is for contamination and build-up of bacteria, the hazard triangle for hygienic risk or poor hygienic design, and the green tick for good hygienic design that's easy to clean. And there we have the mission behind EHED. So it's all about raising awareness in the food industry. Starting with welding seams, which is critical to the design and structure of most of your machines to start with. We want to avoid stitched welds, where we have gaps between parts of weld, because that's going to enable gaps between sheets and crevices and gaps, that it's going to be an area where contamination and bacteria can build up and not be cleaned. So we're looking for smooth, continuous welds, sloped if we're doing an overlap join. Doesn't work on the screen, that's not to worry. When we're welding in the corners, we want to avoid being right in the corner, because that's going to be an area that's harder to clean. General principle, where we've got an internal corner in hygienic design, we want a 3mm radius or greater to make it nice and easy to clean and for fluid and to drain away. And ideally, as you'll see in the third diagram, any welds shown by that black tetrahedron want to be offset from the corner itself. Here on the left is an example of bad hygienic design for dismountable joints. We've got exposed threads sticking through the nut. We've got the shaft of the screw that's also unsealed by the nut, which means that bacteria and contamination can get through the gaps between the metal and build up out of sight and out of reach, as well as gaps between the sheet metal and surfaces. So what we really want to be doing when we've got surfaces joined together is having some sort of rubber or gasket seal between them, and then we have this fastening on the reverse side away from the food product area on top. Traditional machine screws are not ideal for hygienic design. In the first instance, the head features of the screws are going to be a soil trap, whether that's a socket screw style or a pan head or a Phillips screw style. And as you see, countersinks and sunken screws are all going to leave those areas where the soil is going to build up and it's not going to be easy to wash out. When we're looking at drainability, this applies to vessels as well as surfaces. We want to be making sure that all the fluid and the wash down can be drained away by itself from the machine. The general considerations, again, internal corners on tanks and walled sides will be 3mm internal radius as a minimum, and a 3-degree slope for any surfaces that would otherwise be horizontal to aid that self-draining. So who's responsible for putting the hygienic design in place? It's a combination between the food manufacturer, your end user, and yourselves as the machine builder. From the food manufacturer's perspective, the headline of all the requirements they need to be looking at is their food safety management system. That's part of UK law. And for yourselves as the machine builder, the machinery directive, which anyone making automation machinery will be adhering to in the first instance. But if you're doing machines for the food industry, which need hygiene requirements taken into account, you also want to be bearing in mind EN 1672 for food processing machinery and ISO 14159, the safety for hygienic machinery. And by aligning our responsibilities together, we're going to get gold standard food quality systems and design. Are you all aware of BRCGS? A few nods. So BRCGS is one of the leading food safety assurance bodies in the world. They will be the one that you'll most commonly see your end users being audited by when they have annual or biannual checks or going in when there's actually a food safety failure. They released the 9th edition of their global food safety standard in 2022. And one of the biggest changes there was that the end user should create a purchase specification for new equipment. And those of you that have worked across different industries in the past, you've probably picked up the food industry being well behind when it comes to specifications. Pharmaceutical, automotive, even general industry take a lead on that. We've given you as the machine builders clear direction on how the machine needs to be designed and what it's handling. I myself know from first-hand experience going into a food factory and being told we've got a new product which they can't even show you because they haven't started using it yet, and they want to get product from here to here, reduce labour, and that's essentially your brief. The rest is down to us to come up with a solution. But that is all now changing, and the auditors are looking to make sure there's a system in place where the end users are pushing a specification on you as the machine builder. They need to include in there the details of the machine's intended use and the types of product it's going to be handling. They need to think about where they're going to put the equipment so they can effectively clean and maintain it. And somebody from the end user team with authority will need to be involved in signing off that machine before it's allowed into production. And obviously they're going to update all their training, operating and cleaning procedures in accordance with that. On the subject of compressed air quality now, some of you may be familiar with ISO 8573, which actually defines the classes of compressed air quality. It's categorised into physical solid particle contamination in the first column, humidity and water content contamination, and finally oil content contamination. And what that gives you is a 3-part code that's your compressed air quality for pneumatics use. But this is just a standard. It's not law. It's not telling you what you need to do for hygienic design. That responsibility sits with the end user. They should be telling you what the air quality needs to be for that machine. As part of their food safety management systems, their intentions are to ensure that the air quality is clean and represents no risk to food safety, and that it's sufficiently maintained and monitored. Those of you involved in inspection machines may be probably aware of HACCP, the Hazard Analysis of Critical Control Points, and compressed air quality forms part of the prerequisite programme in accordance with that HACCP process. I've loaded you up with loads of information now, loads of problems to think about, so let's look at some solutions. Staying on the topic of compressed air quality, I think one of the best sources of information for a starting point for air quality in the food industry is the paper that the British Compressed Air Society did on food and beverage industry air quality. Their latest recommendation is that the solid contamination should be at a class 1, which is the highest defined class for compressed air quality, class 2 for water content and humidity, and class 1 for oil content. That will be any air that's directly in contact with the food, blowing on the food or even being blown into the food as part of the process. That's their recommendation. Would anyone like to take a guess at what the air quality recommendation is for indirect processes? That's the same. They used to, in their previous recommendations, they had a lower filtration rate. They were recommending 2-4-2. They've now updated that to 1-2-1. And they consider an indirect contact to be anything where air is coming inadvertently in contact with food or food contact surfaces, ingredients, and including packaging. That's their recommendation, 1-2-1 throughout. And one of the things to really note that's of importance, where it changed, was this water content. You'll see there it says minus 40 degrees Celsius dew point. At minus 26, we make pathogens inactive. So that's the minimum we want to be hitting. So the previous recommendations they had in place were below that threshold, which meant pathogens that were in the compressed air were potentially still active. And they're now looking to recommend class 2 on that water content to bring that packaging activity down. And there are various solutions available in the market to achieve that. There are also solutions on the market to specifically kill or capture bacteria in the food stream, as well as bringing that pressure dew point down to a point where it makes the pathogens inactive. But as I mentioned earlier, the air quality should be specified by the end user. So in some instances, for instance with chocolate, we don't actually want the air too dry. When the air is too dry and blown onto chocolate, it will go white with an effect that's called blooming, which some of you might have seen if you put your chocolate in the fridge. And that's why. It's also important to touch upon food-grade grease. When we're talking about machines, there's lots of moving parts, there's motors, there's actuators. So there's going to be lots of products that are being used that are going to have some form of lubricant on them. Food-grade grease is odourless, colourless and tasteless. And you'll see it's been certified to the National Sanitation Federation's NSF H1 grade or the ISO standard 21469. Food-grade grease is advised for a 10 parts per million limit for incidental contact, and that's the really important point here, is for incidental contact. Just because we're putting food-grade grease on the machine doesn't mean that we can then put it in contact with the food. Positioning motors or actuators over the food stream in that food zone is advised against for this reason. And you might even find if you work with some of the protein sector companies doing meat with lots of conveyors, some of them actually ask for drip trays on the motors on the side of the conveyor. There's a growing range of products available for hygiene, and you'll find that most component suppliers do have a range that's designed for hygienic design. There's also a growing number of products that have been specifically certified by EHEDGE, and there's a few examples on there, products that have been evaluated and certified by EHEDGE. So that gives you that additional level of confidence to integrate it into your hygienic machine design. At the start, I positioned that there's not much new I'm going to tell you about hygienic design, but I truly do hope you have learned something new. I also said I'd show you that production uptime will be increased and that hygienic design is not expensive. That is because it aligns with legislation, which means when there's a food safety failure, there's less likely to be some nasty surprises as a result of needing to resolve that issue. Less expense for the end user and less expense on yourselves in time and money if you're called in to help resolve that issue. It does increase productivity and efficiency, so we're going to help that end user clean their equipment using less chemicals, using less resource and time, and that's all going to cost less in cleaning chemicals and time. Imagine if yours was the machine that was the easiest and cleanest to use in the food factory. I dare say that would go down well. And finally, it reduces the total cost of ownership. By having a machine that's hygienically designed, as we've kept covering, it's going to cost less in cleaning materials, it's going to be easier to clean. Yes, it's going to be more expensive, capital expenditure. There's no getting away from that because the products are expensive and putting the principles in place is expensive. But talk with your end users about the total cost of ownership, because ultimately it's going to cost them less.
Thank you very much. Okay, now here's the fun bit. It's the question and answer session. So, do we have any questions from anyone in here? We've got 15 minutes for you. So, oh, just one second. Oh, 1 second. Can I just get the mic to you?
The microphone's coming around to you.
I'm running around. I'm running. Here we go. There we go. Thank you. Sorry. You can.
You showed some bad screw designs. I don't think this is working, by the way.
No, it's for ours.
Oh, okay. Do you have an example of some good ones?
Yes, so I believe there's some on that slide of general products. So essentially what you're looking for as far as good hygienic design for screws, highly polished surfaces. So one of the other things that I didn't cover in a level of detail was the actual smoothness of the surface finish with materials. So you're looking for a 0.8 RA smoothness or better. So you'll see highly polished screws that are put out there as the hygienic options. It's got an integrated blue rubber seal on there, so that's going to stop any contamination debris getting past that fastening head. And the head feature itself, hexagonal head with slopes off. So you might just see it there, but it's been designed with a minimum of that 3-degree slope runoff to help avoid any accumulation of water on there. Is that okay? Yeah, thank you.
Any more questions? Fabulous, thank you. Yes, this doesn't go through for that, but it's for our filming purposes. Thank you.
With food manufacturers now writing more of their own user requirement specifications and hygienic design, to what extent do you think the engineers in the food industry are demonstrating their competence versus the food safety managers in the factories?
So the engineers within the end users. So one thing is with eHedge itself, the eHedge organisation is very much open to representing the machine builders as well as the end users. There's a lot of representation from both. When they're putting these working guidelines together, they want representation from both, and you've got big names in there. You've got the Mondeleses, your Nestle's, your Unilevers, and there's lots of moving around in the food industry. So hopefully it's going to organically filter through, but I don't suppose, in all honesty, at a UK level, there's necessarily anything in place that's going to enforce that to happen through legislation or such. The food safety management systems are there to make sure that everything that's in place is going to be good for food production. But there's not necessarily anything proactive ahead of that, I think. It's a very good question.
Can I offer Camden BRI do excellent courses for engineers on
course,
hygienic
Camden
design
BRI.
if anybody needs some?
Shameless plug.
Nice plug there, nice plug.
But yeah, you know, you're absolutely right though. I mean, Camden BRI, they're a global organisation, of course, but they are based in the UK, and they themselves do a lot of networking and membership groups, so they're really pulling in the end users at that stage. Thank you.
Any more questions? Fabulous, thank you. Right the other side of the room. Thanks. We'll go to yourself first.
So maybe one question, sort of going back to your previous role. What is the most difficult part of an automation solution for food to actually specify and source? Because obviously automation solutions are made of so many different components, robotics, bespoke bits of kit, conveyors. Which is the most difficult part to source?
I think at the moment it's the robotics, honestly. And yes, from my previous role,
I was hoping you weren't going to say that.
That was the wrong question then. Because for me, you know, I'm on a bit of a sort of a personal ambition to really help drive robotics forwards in the food industry, because I've recognised this is the biggest challenge. Yes, we can stick robot systems in at the back of the line to do palletising. That's quite straightforward to cross that into the food industry from others. But it's all about this food contact zone. And that's why I'm really excited to be part of this robotics working group with eHedge to actually help drive that forwards and give people the guidance and insight as to how we can start getting robotics into the food industry further upstream from the palletising end.
Yeah, Oliver rather stole my thunder there, as I knew he would as soon as he got the microphone before me. And my question is very much on a similar line. How much do you think hygienic design has been the reason behind the lack of robots in the food industry?
It's going to be a big reason. When we've been going through this first working guideline for putting robotics in the food industry, it's clear there are lots of issues, and it is going to be difficult for the robot manufacturers themselves to satisfy a lot of the basic principles to get robotics signed off to go straight into hygienic use. When you look, industrial robots, typically they're coated with paint, which is something we want to avoid because it can break away, it can break down. You've got lots of moving parts, you've got moving bearings with grease. Not everything can be made non-horizontal. And another one that's come up in our discussions, putting the working guideline together, you're swinging a robot around and you're potentially splashing contamination into areas you didn't necessarily consider at design stage were going to be affected. So there are lots of challenges.
Another question?
Yeah, Oliver Grant Coffin from Rockwell Automation. So something I'm not, or haven't been involved in is hygienic design. We don't get really involved in the material design of machines. But we do get involved in, safety and safety validation from a control systems perspective. So I'm kind of interested, given this is safety related, if there are methods of validation and things that kind of surround that hygienic design and how that works.
Overall, I mentioned hazard analysis of critical control points earlier, and that's all about looking at the parameters of the food process to ensure that they're being kept at the right levels. If they fall outside of that parameter, it's critical, and it might lead to a food safety failure. So there is certainly an opportunity in the food industry to start putting systems in place to monitor those parameters and keep them logged on a high level infrastructure, so that a food safety failure potential could be highlighted almost instantly, rather than waiting for a manual check that's maybe an hour or 2 hours later, resulting in a lot of lost production last check. So there's lots of opportunities around high level data validation relating to food safety, not necessarily to the physical hygienic design itself.
Still got time for questions, anyone? No? Okay, I know you've
got I've got a bonus slide, haven't I?
Yeah, I remembered this. I remembered it.
So I mentioned that I'm on the robotics working group with eHedge. I'm the co-chair with that. And we've been working on document 62, as it's been labelled up, part 1. And it's going to look at the fundamental requirements for industrial robots in the open food processing environment, looking at the fundamental hygienic design criteria for robots and robotic systems used in wet cleaned environments, the risk assessment principles around integrating that, and then further down the line, once we've done that first part and got that published, we're then going to look onto other bits and pieces. Part 2 I'm looking forward to being involved in, which will be end effector design. So that's going to be something that I'm sure will be really relevant to a lot of you. We also recognise that, for instance, service robots and self-guided vehicles, whilst we're staying well ahead of the curve in looking at robotics in the food industry full stop, we need to keep ahead and look long term and accept that there might even be a wish to get more AGV type robotics into the food industry, like we're starting to see in the pharmaceutical and automotive industries. Well, thank you for your attention, everyone.
Thank you very much. Thank you. Okay, so next up we've got Ben Cayley. He's from Siemens, and his talk is all about cybersecurity. I can't remember, but I was somewhere the other day and I found some stats about cybersecurity, and they were quite scary, to be honest. So I'm sure people are kind of nodding their heads. So yes, this is going to be an interesting talk as well. So Ben is the product management for Siemens Digital Industries, connectivity and cybersecurity business within the UK. With a background in industrial automation, IoT and cybersecurity, he has all of the credentials to advise us on what is presently, and as I just said as well, a very serious and hot topic. So please welcome Ben Cayley to the stage. Thank you.
Thanks for the introduction. Good morning, everyone. Welcome to the next session. As you've heard, we'll be talking about industrial cybersecurity, and in particular, the challenges around cybersecurity when we're looking to adopt IT-OT integration. So you just heard a little bit about me. I'm a product manager at Siemens, so I look after our cybersecurity and our networking portfolios for the UK and Ireland. I've been with Siemens for coming up for 10 years now. First half of that was looking at digitalization, IoT, big data type topics, and I've been focused on cybersecurity for the last 5 or 6 years. So I just said we're going to focus on IT-OT integration, so I thought I'd better explain what I mean by that first. So IT is something that everybody will be familiar with. Information technology, business information systems, we know what that is. By show of hands, has everybody come across the term OT before? Okay. You will all be familiar with OT. It's just sometimes it's not the way that everybody refers to it. So operational technology, or OT, is effectively industrial tech. So it's everything from the field level, sensors, actuators, pumps, motors, through to your PLC level, SCADA, MES. And it's at that level that we start to draw the line between what we call OT and IT. So it's basically your industrial control systems. So we know what IT is, we know what OT is. IT-OT integration is where we bring the two together, right? So we're seeing a massive trend of this. I'm sure you all are, with your customers demanding more and more data out of the systems that you're putting together. Or if you are an end user, starting to get more and more thirsty for data. Could be for condition-based monitoring. It could be for measuring the efficiency of a machine. Could be for remote access. How many of you are using remote access in the machines you're building or asking for remote access? Okay. All of this brings massive benefits, all of these digital topics, and we're not disputing that for a second, and actually at Siemens we want everybody to make the most of these new digital technologies. But we've got to accept that with these added connections into our industrial systems does come extra risk, because we're opening up what we call the attack surface. We're basically making more routes in and out of our systems that somebody could take advantage of from a cybersecurity point of view. So we really are moving from islands of automation where we had air-gapped systems. It might be individual machines that were air-gapped, or it might be whole production lines that were not connected to the outside world, to having lots and lots of touch points, whether that be remote access or IoT sensors or connecting your MES system to ERP, for example. Another way we can look at this, if you're like me, data sometimes paints the picture and kind of helps to click things together. One way that we can quantify digitalization or quantify IT-OT integration is the number of connected devices out there. This is a graph showing the number of connected 1 billion devices up until about 3 years ago, which is the latest data we've got. And we're not just talking about smart TVs and your Apple Watch and number of phones people are carrying around. These are now industrial devices as well. And you might be thinking, connectivity is not a new thing. We've been connecting our machines to the outside world for a long time. And you can see that is true. It's not a brand new concept. However, the rate of adoption is really accelerating. It's truly exponential. And what we can, you might not be able to see at the back there, the bottom of the screen here, but we've got another graphic which is showing another exponential curve, which is the number of industrial cybersecurity incidents. And it's alarming how the two are that closely correlated. So the message is, make the most of the opportunities of digitalization, but make sure you're thinking about cybersecurity when you're designing these systems. Because in our experience, if you do think about cybersecurity and build it into your design and think about it when you're getting your data out, you're probably going to end up with a more secure system than you did in the first place. It's not a reason to shy away from digitalisation. It's not a reason to say, no, this is too risky, we're not going to do it. Just consider it from day one, and you can build it in, and I'll show you some of the techniques that you can use that. So digitalisation is one challenge that we've got in the world of cyber at the moment, but unfortunately it's not the only challenge. We've also got a big challenge around skills and engineering skills. So I can see some people nodding in the audience. I expect you're seeing very similar challenges to we are at Siemens in terms of getting the right automation engineering skills, people with the right technical backgrounds. And that's hard enough in itself. If you're then looking for people who not only understand the automation systems, but also understand the cybersecurity elements of that and how do we protect an automation system, that Venn diagram gets even smaller. So the people who understand both of these worlds are incredibly rare. And while there are some really great schemes that are starting to try to address this, they're all going to take time. So we've just taken on our first industrial cyber apprentice in the last 6 months, which we've never done before, which is fantastic. However, he's on a 4-year program, so it's going to be at least 4 years until he's into the main workforce. There are other schemes run by the government, so the National Cyber Security Centre, or the NCSC, runs something called Cyber First. If any of you have heard of that, have a look at it. It's a really interesting way of getting undergraduate students into your business for a summer placement, specifically to look at cyber security. So the government actually do the training for them. They get trained up on cyber, and then they can have some impact in your business. So there are some good things moving in the right direction on the skills topic. But it's all going to take time, and we are going to have a significant challenge here for the foreseeable future. Another challenge is around legal regulations. I'm going to spend a fair bit of time talking about this, so I won't labour the point now, but across the world, regulations are going to be hitting, and they're almost certainly going to affect everyone in the room one way or another when it comes to operational technology and cyber. And globalisation, finally, again, you might be thinking, well, this isn't a new challenge at all. Globalisation's been around as long as we've been doing what we do. However, it brings some specific nuanced challenges to cybersecurity. People are wanting data to be produced in one country and then sent and stored in the cloud on the other side of the world. What impact does that have to cybersecurity? People might be looking to have an engineer sat in India doing remote access to maintain or troubleshoot a machine that's sat in the States. What does that mean in terms of cybersecurity? The legislation differences across the world as well. You can see how, because now we're living in this global environment, it makes everything just that little bit more complicated, and the same is true when we're thinking cyber. So all of those challenges result in real cyber attacks, and cybersecurity is hitting the headlines more than it used to, for sure. But I think manufacturing attacks are massively underreported. So if you're anything like me, these numbers might surprise you. 61% of smart factories have had some sort of incident. So a smart factory is a factory where they're employing some sort of digitalisation, which is the majority. 61%, it's over half. We're certainly not seeing all of those reported in the news. A third of cyber incidents are happening in manufacturing. And we'll look in a minute at some of the reasons for that. And in particular, ransomware attacks are the ones which criminals are focusing on the manufacturing sector. So ransomware is a specific type of malware which effectively renders a production line completely useless, stops manufacturing, effectively bricks the whole system and holds you ransom. That's where the term ransomware comes from. And as you can imagine, cyber criminals aren't the most honest of people. They are not always going to give you your system back when you pay the ransom. So although a lot of people do end up paying them, we would absolutely never recommend that that's the route you go down. The reasons that manufacturing is so attractive to these criminals we'll touch on in a second, but it's because in a lot of cases we do leave our OT systems quite vulnerable, and also uptime. The plant producing something, they know that is our moneymaker. So as soon as you knock that out and you're holding somebody to ransom, they're not able to produce what they were producing, that's costing the business money, and people are more likely to get into a panic and pay that money. Okay, so that's the stats of how likely this is to happen to your customers or even to yourselves. But what does it actually mean? What are the risks to the business? Just talked about plant standstill or downtime. That's probably the one that keeps most end users up at night the most. But it's certainly not the only thing to consider. You've also got to think about the fact that for somebody to get into your system, they could potentially then be in there and making changes to your PLC programs, changes to the way you're collecting data on your SCADA systems, and what impact is that going to have, not only on your production, but the products that are flowing out the other end of the line. Can you trust those products? Can you still sell those products? Is there going to be a quality issue? You may not even pick up on the quality issue. I'm going to mention standards again in a moment, and that's going to become more and more of a hot topic because the fines involved are quite eye-watering. Intellectual property is another thing. Maybe that's not relevant to all end users, but recipes and IP is the absolute kind of golden egg for a lot of companies, and cyber criminals are interested in that just as much as they are in stopping your factory from producing. And lastly, we heard about this in the last presentation, reputational damage. The damage to a brand can actually be more costly than the attack itself. So there's all of these things to consider, and these different risks will be in different levels of priority for different businesses. You might have two factories that are on the surface producing pretty much the same product that's going out the door, but they could have very different attitudes towards risk, and one of them may be far more concerned about their reputational damage than they are about uptime, for example. One may find that it's, or may think that its recipes are the most important thing to their business that they hold most dear, whereas next door, actually, they're not too bothered because they're contract manufacturing something for somebody else. It's made all over the world, for example. So this is always the first conversation we have with people when we're talking cybersecurity is, what do you see the risks? Point maybe some of the ones they haven't thought about out and work out where they are ranked in priority. And one of these, as I've already mentioned, is all about legislation. So legislation is underway across most of the world now. Are you guys exporting your machinery across the world? I expect you've got customers in the UK, but I expect it's also not just the UK that you're sending your machinery to. The US have been a little bit ahead of the game. They've had regulations out called NERC-CIP for a while now. It's a really hot topic in Europe at the moment because we've got legislation which has just been launched and more coming in the next couple of years. I'll touch on that in a second. But if you're exporting to Asia and China, there's also regulations there. So I mentioned the challenges of globalization earlier. Although these are often pointing at very similar concepts, it is different legislation in different parts of the world that you've got to try and get your head around. So let's focus on the European legislation, because this is probably the closest to home for us. Although we're not part of the EU anymore, if you're trading with EU or you want to place a CE mark on your machines, which I expect an awful lot of you will be doing and want to continue doing, this is going to become incredibly important. So there's three main ones that we'd pick out. First one is the NIS2 directive, NIS2, and this is mainly aimed at the end users, the people who are running the factories. However, it's not just what's the word I'm looking for? Restricted to their scope. If you're supplying to an end user, they will be coming and asking some potentially difficult questions about what you're supplying to them when it comes to cyber. So as an example, if you're supplying to somebody in Europe who falls under the NIS2 directive, you will have an obligation to inform them if there's any cybersecurity vulnerabilities with equipment that's within your machine or the system that you've handed over, just like you do with safety. So at the moment, if there's a safety recall on a PLC or an e-stop, which is part of your system, you're informed about that by the manufacturer. You then have to inform your customer. Makes sense. Everybody needs to know that there's a safety issue. Well, the same is going to be true for cybersecurity. The main two, which I think will be most relevant to this audience, are the middle and the right-hand side, the Machinery Regulation and the Cyber Resilience Act, because this very much is aimed at people who are creating products and systems. So let's have a look at them. Oh, last thing on that before I move on. You may not be able to see at the bottom some of the dates here. It's really important to point this out. So the NIS2 directive went live last year, 2024, and there's a grace period for implementation. So if you haven't heard about that yet, I'm sure you will very, very soon. The next two are both going live in 2027. So as I'm talking about the details in a second, just bear in mind that the clock is ticking and there's a couple of years before this goes live. So this is a big topic in itself, and there was a really good Automate UK webinar with Rockwell a couple of months ago, I think, on this topic, and it really is something you can talk about for an hour in itself. So I kind of skimmed the surface and referred to those other webinars. There's lots of really good information out there. We've got it on our website. You can find lots of really good material out there. But there's a couple of things you really need to have in your head. The main thing for me is the CE marking. So both of these, the machinery regulation, which is taken over from the Machinery Directive in a couple of years, and this CRA, Cyber Resilience Act, they are both going to become prerequisite requirements for you to place a CE mark on your machine. So just like you have that long list of directives and harmonised standards which you have to adhere to now to place a CE mark, that list is going to get longer, and cybersecurity is going to become part of that prerequisite for you to have your declaration of conformity. So how do you go about proving that you are compliant? We always point people towards an IEC standard. You've heard a few standards today already. Here's one more for you. IEC 62443. Anybody heard of that before today? We've got a few hands in the... If I'd asked that 2-3 years ago, we wouldn't have had any hands in the room. So that's good progress. But this is, from my point of view, cybersecurity-wise, this is the standard for you to go away and have a look at in detail. This is the harmonised standard which you can use for presumptive compliance in your declaration of conformity. And I've been focusing on the European regulations, but you can see there are government agencies across the whole world who are accepting 62443 as the international standard. So it's specifically cybersecurity, and it's also specifically industrial cybersecurity. So it's not looking at IT systems, it's talking the language of industrial control systems. And if you're a control systems engineer, or in your teams you have them, it will be talking their language and be something they can understand. This is the standard that we've been working to at Siemens for many years now, because just like many of you, we have customers across the whole world, so we need an international standard to standardise on. But also we've got factories across the whole world. So when we're producing our equipment, both our factories and our products are certified against this, because then it's the same piece of paper whether we're selling in Europe, China, America, wherever. So 62443, I'm going to mention it a lot more times. Hopefully it'll be in the back of your head by the end of this. Okay, so we've talked about the business risks and the impact on the bottom line. We've talked about the legislation. So let's try and play out a couple of real scenarios, see what this could look like. So first scenario, production has a downtime because of a cyber attack. Somebody's got into the system, and for some unknown reason, your production stops. You realise it's because of a cyber attack. So you've not only lost the production for the days or the weeks, or we've even seen the months that people have their production cut out because of the cyber attack, but also you can't necessarily trust the product that was flowing out of the door in the time leading up to that, because the cyber criminals are often sat in your network listening and watching and working out where the best place to strike is, when the best time to strike is. So who knows what they were doing in that system in the time running up to it. So you've also wasted a load of product that was produced beforehand. In that time they're sat in your network, they've also got hold of your PLC code or your recipes, and they've been able to sell that on the black market. That means that a journalist has got hold of it. Journalists are scouring the black market to see what's available. That means they know that you or your user, your end user, your customer, has had some sort of cyber attack that they were trying to keep out of the press. So the upshot is products can't be delivered, you've wasted time, orders are being cancelled because of the reputational damage. And in this particular case, the factory was actually part of critical national infrastructure. So this is having a knock-on effect not only to the company as an individual entity, but also to the wider society and the country itself. I know this sounds like a little bit sensational, but this is really happening all the time, and it's one domino falling can have all of these consequences. So that truly is why you need to start thinking about having a comprehensive cyber concept. Okay, second use case. We've just heard about the cyber regulations getting tighter and tighter, and you can't comply with the standards because of the way that your machine's been designed. The products you've chosen to build your machines with don't have the right certificates, they're not built to the right standards. And because you're part of a supply chain, you are also liable, as well as that end user, if there's a cybersecurity incident. And go and have a look at some of the fines, because they'll make you sit up. It's dependent on the turnover of the company, but it can be in the 6 or 7 figures for these fines. And the reason for that is we're linking cybersecurity with safety. If you think about it, everybody understands the importance of safety. However, you're often running safety systems over a network or over a system that could have a cybersecurity incident. So if you have a denial of service attack, that means your safety network no longer works. Somebody could get seriously hurt, and all the same implications. So because of that, the HSE are becoming the kind of competent authority investigators for cybersecurity as well as safety. That's where all these standards are interlinking, and the 62443 standard I mentioned earlier, that's already referenced in a lot of the safety standards that you'll be using, 61508, things like that. Okay, so hopefully that paints a picture of why should we worry about this? Why is it real? Let's talk about now some of the things we can start to do to build into machine design or speak to with your end users to start plugging some of these gaps. So the first point is we've talked about IT, we've talked about OT. The first thing we need to kind of accept is that although we have similar technologies in both of these worlds, we still have IP networks in IT and OT. We have PCs, we have switches, firewalls. We have these weird things called PLCs in our world, but IT people don't seem to care about that. They just brush that under the carpet. And they think that they can treat OT the same as they can IT. Absolutely not. That's the reason that we have specific standards, and there are some really good reasons for this. Operational technology fundamentally is trying to do some very different things to IT, but also it looks very different, as I'm sure all of you are aware. So first thing to point out is lifespan. Just by show of hands, how many of you have worked on a machine that's 5 years old, at least? What about 10 years old? 15? 20? 25? Or we're getting outbid now, yeah.
You're getting into ages now.
How far can we go then? What's the highest number we got to?
It's at least 30 years.
30 years old? Okay, yeah. 40-year-old machinery. Okay, show of hands if you've got a 40-year-old mobile phone in your pocket. Or a 40-year-old laptop. Oh, you've got one at home, right, okay, yeah. But we're forced to upgrade our IT equipment at a life cycle of, what, 3 or 4 years? 4 years, we're probably throwing our laptops and getting a new phone. But these machines, they are out there for 30, 40 years, and they've got to still do what they're doing, and we can't throw the baby out with the bathwater because of cybersecurity. We've got to find ways of protecting that older equipment, and that is something that IT departments often don't have a grasp of. Another example is around patching. So I'm sure I literally had this yesterday. Have you all experienced the frustration of having a forced restart when you're in the middle of something because Windows needs to do an update? Yesterday for me, it was Outlook forced me to, I'd snoozed it probably about 7 times already, but then had to do it. I'd run out of time, and you know what, our IT department doesn't care that it's inconvenient. They gave me the chance to snooze it, and it's more important that I have the update than it is that I lost half that email. Imagine if you did that for an industrial plant. Imagine if you did that. You said, I don't care. Cybersecurity is the most important thing. We are patching this at 2 o'clock in the afternoon in the middle of a production run. I don't care if it's inconvenient. You just can't live like that, right? And because of that, you need okay, we need to do patching in both worlds, but we need to handle how we do that topic in very different ways. And the last point, which is the bottom here, is around our protection goals, what is fundamentally the crown jewels for us in these two different worlds. In the world of IT, confidentiality is often the most important thing when it comes to data. So as an example, if an encrypted email takes half a second longer to get from A to B, is anybody going to notice? Probably not. It's probably worth that extra half a second to have the security of that confidentiality. Half a second in a real-time machine or an automation system, imagine the impact that would have. You can't just start sticking, for an example, a firewall in the middle of an automation system with cycle times that are going to start adding that level of delay. So again, we're talking similar technologies. We do want IP networks. We want to see firewalls in an automation system, but we can't just slap in the same old IT ones and use the same way of programming them. We've literally seen this before. I can't obviously mention the company involved, but think they're doing the right thing by putting firewalls in, and suddenly all of their I/O stops working because they're meant to be working at millisecond timeframes, and suddenly they're up to kind of half a second. So these are different worlds, and we need to treat them differently because of that. So that was the first main point. IT is different to OT. Second main point, this is something that's referred to throughout the whole of the 62443 standard, defense in depth. So what we're trying to do, move away from this left-hand scenario where we've got one single wall of defense, over to the right hand where we're saying we've got multiple independent layers. So this left-hand side is a lot more common than you might think. In most cases, that wall, people think they're safe because they've got an air gap. Their machine or their system isn't connected to the outside world, so I don't really need to worry about cybersecurity. There's no way for people to get in. I don't have remote access. I'm not doing IoT. And okay, you've got one layer of defense there, but that is not infallible, and people are able to get over that wall. As soon as they have, they're into your crown jewels. So what we're trying to do with defense in depth is admit that people are always finding new ways of attacking, admit that people make mistakes, and there will be people on the shop floor, there will be maintenance staff who aren't perfect and might leave something open when they shouldn't have done, or accidentally plug in a USB stick when they shouldn't have done, charge their phone up to watch Netflix in the middle of the night shift, whatever it might be. Again, we've really seen this. Those things happen, so we need multiple other layers of defense. If somebody gets over them, then you've got other means to stop them on their way through. So that's what we're aiming for with defense in depth. But obviously, what does this actually mean for a control system? So we've kind of split this up. Defense in depth is not a Siemens thing at all. It's an industry-wide term. We've tried to organize it in three main areas to try and make it a little bit more digestible. First of these, system integrity, it says at the bottom there. What we mean by that is taking every element of an automation system, so looking at every PLC, every switch, every drive, anything that's on that network, and asking the question, is it as hardened, is it as secure as it can be? Have we switched off the ports that aren't being used? Have we turned off the features or the protocols that aren't needed? Don't stop the system from doing what it needs to do, but don't let it do any more, because those are potential vulnerabilities. It's also asking questions about, is it running the most up-to-date firmware? Have we put user access controls in there? And how good are those user access controls? Is it literally that we've got an admin user and an operational user and everyone shares the same password? That could be okay, it's better than nothing. But as you go further up these standards and look at the higher levels of security, you might need to do things like multi-factor authentication. You might need people logging in with ID badges as well as a password, this kind of thing. So system integrity is basically asking the question of every individual component of the system, have we looked at it and made it as secure as it can realistically be? Next level is then about connecting those individual components together. So how do we design a network that ties everything together in a secure way? So are we segmenting the network with firewalls? The reason we might do that is to stop incident spreading throughout a factory-wide network. Again, admitting the fact that bad things do happen, but let's contain it to one area of the factory rather than it rippling all the way through. It's asking questions about remote access. A lot of you said you were doing remote access already. Hopefully you're doing it in a secure way, but there are lots of good ways and a lot of bad ways to implement remote access. Are we doing that in a secure way? And finally, we zoom all the way out and look at the plant. And you might be thinking, if you're a machine builder or an OEM, well, this isn't relevant to me. This is where I pass the machine over and it's somebody else's problem. And that may be true, but you need to be aware of all of this and have an active conversation with your customer. Work out where the line is drawn between your responsibility and theirs, because we find all too often that everybody's always pointing in the other direction. The machine builders assume that it's the end user's responsibility, and the end users are assuming that, oh, well, I'm being delivered something that should be secure because I asked for it. So plant security, we're talking about physical things, the basics of, are panels locked? Is there CCTV up? Do you have to wear a visitor badge when you're going around the site? The basics like this can have far more impact than any fancy technology that you're implementing on your automation system sometimes. Policies and procedures I'll talk about again in a sec. But this is saying that we need to bake into our way of working cybersecurity. How many of you have to do mandatory cyber training on the IT side of the world? At least once a year, probably, sitting through some web-based training, if it's anything like us. Yeah. Well, we should be doing that for people on the shop floor as well. They should be understanding their responsibilities when it comes to the security of the production line as well as the IT systems. And monitoring is also important. We're saying that bad things happen. We need to know when they do. It's effectively having that burglar alarm, but on your automation system. And you can see there how those independent layers are building up. And that is what defense in depth looks like for real in an automation system. If that felt a little bit like, whoa, there was a lot there, this is how it boils down to its most simplistic form, if you ask me. So cybersecurity is a bit like a three-legged stool. You need all three legs to be equal in length and also in strength. So technology we've talked about the most, because I'm an engineer, I expect a lot of you are engineers, and we're drawn towards technology will solve all of our problems. And it is an important part of it, but it's certainly not the whole story. Talked about processes already, and what that IEC 62443 standard does a great job of is putting equal importance on the processes and the procedures as the technology. As an example, you could spend a load of money on a great vulnerability management solution. So you get some software that tells you every time you have a vulnerability, it flags it, helps you to manage it. You think, great, I've got the software, that's perfect. But have you got the process that actually explains when that patch should be applied? How do you rate the risk of it? Does the person whose responsibility is to do that know that it's their responsibility to do it? If you don't have the processes in place, that nice piece of software is potentially just sitting there not doing very much at all. And we've also touched on the last point already, which is around people. Training of staff, competency of staff, people are often the weak link which are exploited. The attackers know that people are often the weak link. This is often one of the easiest places to have quick wins with some training and some general awareness for the people operating the machinery and the equipment, as well as throwing all of these great technological solutions as well. So all three equally important. And this is important all the way through the life cycle of a machine. So we've talked in general terms so far, but you might be thinking, okay, well, where does this fit in my world really? Well, when you're designing a machine and assessing the user requirements, you need to be thinking about cybersecurity. You need to be getting the user requirements. You need to be asking, which standards do you want me to work against? Do you want me to be compliant with the machinery regulation and the CRA, even though it's 2 years away? Should we do it? Let's do it now, right? Let's get ahead of it because we know it's coming down the line. Once you've done your design and you're actually doing the implementation, again, you need the policies and procedures to make sure you're doing that in a secure way, just like you would with safety. When it comes to operation, this is really where the end user's emphasis starts to shine through the most. But if you're involved with the maintenance of the equipment that you're installing, if you've got SLAs, if you've got service contracts in place, then you also have a responsibility to maintain the cybersecurity of that machine. And I've also already mentioned the whole notification of vulnerabilities in the same way as safety. So if you're a machine builder, it doesn't just stop here, you've got to consider the rest as well. And this this is making it look like a linear process. Really, cybersecurity goes round and round, because if I came back and presented next year, I expect we'd be having a different set of like top attacks, different ways that people are getting into these systems, because that threat landscape is changing all the time. So it's not a one shot and done. It's something that continually needs to be monitored. And again, this is exactly what the standard's pointing you towards. So the last thing I wanted to show you is something that we think is particularly useful about this standard I keep harping on about, the 62443. What it does an incredibly good job of is explicitly explaining those roles of where does the line stop between an asset owner who's operating a plant, system integrator, and a product supplier. And you can see on the right-hand side there, I haven't gone into the details of this, but 62443 is a big old standard. It's got lots of different parts, but it's split up in a way that you only need to focus on the bits that are relevant to you and the role you're playing. So as a Siemens, Rockwell, we're product suppliers. We're producing the PLC, SCADA systems, switches that are used to build up the machine. We are looking at 4-1 at Siemens and 4-2. So these are the bits that we're focusing on getting our certification for at the moment. All of our factories are 4-1, for example. When you then take those components and build it into a machine, and that machine is then built into a automation line, start looking at system integrators. And this is saying that we don't just care about the products themselves being secure. Okay, so we know that they've been made in a secure factory. We know that they've got the right security features. That's what the bottom line is about. But the system integrator has now got a responsibility to integrate it in a secure way. Again, you can think of this like safety. You can buy safety-rated kit, but if you don't engineer it properly, you don't get the rating. Very similar here. And then we've also talked about the importance of the asset owner and the responsibilities they have. And this will be different depending on whether they subcontract their maintenance or whether they do it in-house, whether they've got their own engineering teams or whether they're, because if they're subcontracting, they're also putting responsibility onto that contractor. But ultimately, the asset owners own the risk for their plant. The reason that these arrows are flowing up and down is although they have ultimate responsibility, I mentioned earlier that legislation is still relevant to everybody on the slide, and those requirements flow downhill, and your requirements, your capabilities should be flowing up the hill. So, as a bit of a summary, and feels like we went through quite a lot there, 3 main things that we would recommend going away as food for thought. First one is get informed about those regulations that we mentioned, especially the European ones, but look at the markets that you're working in, you're exporting in, and get informed on those. Like I said, there's already some great content out there from Automate UK, but there's also a lot of reading you can do around the subject. That's point 1. Point 2, understand the relevant standards. I focused on 1, 62443, that's where we would definitely recommend you start looking. But as you read into the subject, you'll realise that there are some others as well that you can look at, 62443 being the one that we would focus on. And then finally, and really importantly, start talking about cybersecurity with your suppliers and also with your customers. If your customers aren't already asking you and building into their requests for tenders and their specs cybersecurity requirements, you should be asking them why, really. Because in 2 years, you can guarantee they will be. So this is actually an opportunity for machine builders and integrators to potentially get ahead of the game and offer something that maybe not everybody else can. That's what you need to be talking to customers about, so you know your requirements. But you should also be asking the questions of your suppliers. Once you've got your head around what your security requirements are, ask them, where's the certificate, the 62443 certificate for the products that I'm buying from you? Where's the certificate for your factory that you've produced this in? Because it's by building up that base of evidence, you've got your DOC, your Declaration of Conformity, and you've got that CE mark on your machine that is still going to be equally important in 2 years' time. So that'd be the 3 things that we really recommend as a place to start.
Thank you.
So thanks very much.
Thank you. Really interesting. Thank you, Ben. I think I listen to that and I think, gosh, you don't realise how vulnerable you are, and you've said that word quite a few times. So yeah, really interesting. Okay, question time. So I've got the mic. Yes, straight away. Okay, let's go.
I'll make it easy for you. Thanks for the presentation, really good. I'm from Muscada, we're a systems integrator, and I liked, I think it was like slide 20, where it showed the sort of cyclical version of how the end user, the systems integrator, and the OEMs sort of work. We're both a Siemens and a Rockwell partner, so we have constant sort of codes of practice to work with, some cybersecurity. And because we're the sort of middle people, the systems integrator, like you say, the consequences of a cybersecurity attack, there can be finger pointing, and you know, it's not just the end user that's going to take the consequence, it's going to be passed down the chain. So we have also a third party that we invest in to have like training and more reactory sort of training processes for cybersecurity. And this is a question that's a little bit holistic, but what's been done to be preventative? So a lot of the training processes that we go through have case studies that said in 2023 this company had X leak through phishing, malware, ransomware, poor clean desk processes. Is there anything that's been done that's sort of ahead of the curve? So it's not because of this attack, it's we imagine that there's a level of vulnerability here.
I think I know what you're saying. Yeah. So something I haven't mentioned and is really important is also how you recover from an attack that's happened. So that'll be part of the training that you're talking about there. The training we would recommend is run by the ISA. So I mentioned the 62443 standard a lot. There's training run by the ISA who write the standard specifically for design of systems, management of systems. I can't remember what the third one is, but there's 3 different specific courses you can do. If you do all of them, you become what they call a specialist, and that is allowing you to basically do the training that's right for you, if that makes sense. So if you're not maintaining the system, don't do the training on that. If you're designing the system, a risk assessment is the other one that they do. So that's what we would point people towards, yeah. I can share the details for that afterwards if you ask it. Yeah.
Any more questions? No more? Yes. I'll go back. Oh, there. What's the best way to do this? Sorry. Thank you. Oh, thank you.
You talked about legacy machines, old machines out in the site, in the field. What's the methodology for protecting or assessing those? We've got thousands of machines out in the world for mostly Rockwell and various other systems, but not all Ethernet. Some of them are data highway, some of them are device net. You know, there's lots of different protocols. So what's the vulnerability? So if they're not connected to a network, where's the vulnerability, and how do we defend against that?
Really hard question. So they absolutely are still vulnerable. That's the first thing to say. Don't think that because there's no Ethernet network or no connection to the outside world that they're not vulnerable. The first really widely publicized or kind of reported on OT cyber attack was something called Stuxnet. Some of you might have heard of that. It affected us at Siemens. It was a Siemens control system which was being run in a nuclear facility. It was the first time that an OT system had really been targeted, and it was an eye-opener for the whole industry. It's what made everybody wake up to this. Unfortunately, we were at the other end of it. But that was back in 2006, I think. So yeah, it was a while ago. I'm wondering if I got my dates right then. Yeah, I think so, yeah. So yeah, that's the first thing. Don't think it's not vulnerable. In terms of what you do to protect it, you need to do a risk assessment. It sounds like a bit of a cop-out answer, but you need to look at the machine. Each machine is going to be different, right? And what you're looking to protect against is also going to be different. So it might be things like, as an example, if you've got an old PC as part of that machine, if it's running XP, and you can't update it because the software only runs on Windows XP, rather than putting on some malware protection, which is like an antivirus, we might recommend something like whitelisting, which is very lightweight software, and it says that, okay, we're just going to lock down and only allow that PC to run the software that is running on day one, if you see what I mean, on the day that the whitelisting is installed. You can obviously do things like putting firewalls on the edge of a particular cell, more firewalls than you otherwise would within the network. Policies and procedures can often play a really big part in legacy equipment as well. So maybe if the only way of getting data on and off of that machine is with a USB stick, as an example, and your general policy is we hate USB sticks, you're not plugging those into our machines, and you say, well, hold on, this one's 15 years old, it's the only way we can interface with it. Okay, well, what mitigating action can we put in place? Maybe you have to scan that USB stick every time as like a sheep dip, we call it, before it's then put into the machine. So that it's literally looking at every individual case, and that's where sometimes you do need a consultant. So we've got a team of consultants who literally spend their days looking at the intricacies of problems exactly like that. But what's nice about the standard is, the 62443 standard, is it does give some leeway for the realities that you're talking about. So it's there's no, I can't give you a tick list of things that you need to do with all your old machines, but you definitely still need to consider it, and don't think that there aren't any options, because there certainly are.
So, I mean, the nitty-gritty of it as an OEM is where does our liability lie? So we've got like all these machines out in the world in various food factories and whatever. Some of them or all of them are potentially vulnerable. So what, from a purely selfish point of view, what are our liabilities? Do we need to proactively address that, or do we wait for our customers to come and say, what about your machine, or do we wait?
You like asking hard questions, don't you? Yeah. My recommendation would be to be proactive and get ahead of it. We've done a really short version of a really complicated topic with the regulations. So I wouldn't want to give a short answer to something that is actually quite a long conversation, if you know what I mean. Like I say, I would recommend going and doing some investigation, go and speak to the experts. But it is it's something that giving broad brushstroke answers is sometimes more damaging than good, if you know what I mean. Yeah, so sorry again if that's a bit of a cop-out, but yeah. Yeah, absolutely.
And that's what the networking at the end can help with.
No, Grant makes a really good point. It's an opportunity, because if you can get ahead of it and you can be the only person asking that, you can ask another awkward question to the customer of what are you doing about this. They will then question all of their suppliers. If you're the only one with an answer, who are they going to choose? Yeah.
Okay, so as a system integrator, in 2 years' time, we'll have to look at CRA as a way to also sort of put that CE mark on any equipment. Are there any good examples of risk assessment or cyber risk assessments? Because that's something we don't necessarily always do to the level we probably will have to do in the future. Or will that come with sort of external training that we'll probably have to send our people on?
The people, there are two options, right? A bit like when safety was new. Some people decide to go down the route of getting skilled up in-house, do the training, get certified, and you can make your own decisions, and you can place your own CE marks on, etc. In that case, the ISA training I talked about is really good. There's specifically a risk assessment module part of that. It's really good. You can go to another level of detail as well with things like SANS courses. Again, I can share details of these afterwards if you like. But not everyone we speak to wants to go down that route. Some people say, you know what, we are the experts at making the machines that we make. Cybersecurity is not our bag, and it may never be our bag. That's when you can go to external providers who not only give you the consultancy through the risk assessment, but can also give you us as an example, we would also be involved in the engineering of the machine itself, all the way through to validating and verifying it like you would safety. So absolutely, you can train your people up. You can get to the point where you're certifying yourself and putting CE marks on. You can also do that externally. Yeah. Oh, yeah, I can do. Yeah. It's, yeah.
Voice. As we're talking about levels of, I think in my head it compares to how we do safety. So that SL rating is effectively what I'm being asked now from the machine builders we're talking to in terms of what level do we need to comply with.
Absolutely. So we made a simplification for the purpose of the presentation, really, talking about the standard. If you comply with the standard, I talked about the different parts of the standard. The simplification I made was there are different levels of protection that you and your customers and the product suppliers can aim for within that standard. So between levels 1 to 4. That's made up of 2 parts. The SL, security level that Rich has just mentioned, is all about the technology. And that ranges, like I say, from 1 to 4, 4 being the highest, 1 being the baseline. You also have what they call the protection level, or the PL, and that's all the policies and procedures, the softer side of things. So we talked about the concepts, didn't get into all of the nitty-gritty of it. But basically, I've just made a mistake there. I talked about protection level. I meant maturity. This is why I didn't put it on the slide, because it becomes a mouthful. So you've got the security level, which is technology. The maturity level, or ML, is the policies and procedures. Those two come together for your protection level, and that is what the end user ultimately cares about. They want a protection level, and what the standard's trying to do, as I mentioned, is put equal importance on the technology and the policies and procedures. So they need both of these to be equal parity before they can get their protection level. And we've seen it. We've been asked to come in and audit people who basically wanted us to come in and give them a pat on the back and say, excellent, we think we're reaching protection level 3. Can you come as a third party, come and sign that off and give us the rubber stamp? We did the audit, and they absolutely had hit security level 3 for their technology. They'd done all the right stuff, but they didn't have a single policy or procedure to back it up. So their maturity level was at a 0, and that leaves their protection level at a 0 as well. So it's working out where you need to ask questions of your suppliers. What level is relevant for them? What are you aiming for when you're designing your machines? And ultimately, what's the end user asking?
Any more questions? Yeah. Let's pass that through. Thank you.
You talked about the difference between people who are working on OT and IT people. If you want to train somebody in IT up, so you have one approach to cybersecurity, do you think that person has to have a prerequisite knowledge of engineering?
You've got to train people one way or the other, basically. So it's more common than not is what we see is what you've just described. The IT department, especially in smaller companies, own the cybersecurity topic. And then, depending on the personalities and depending on their kind of view of the world, they might ask an engineer to become part of a working group and help them upskill and understand the nuances of the OT like we talked about. But in other companies, we see that actually the OT security lives in the engineering department, and they're upskilling the other way. So they're taking an engineer and training them on the cybersecurity side of things. I don't think there's a right or wrong answer. In some companies, we see people have both, and actually there's a line in the sand where the engineers don't trust the IT and the IT don't trust the engineers. And it sounds like a negative, but actually you want to think of your systems a little bit like that. From the engineering side, you want to think of the IT network as this dirty thing connected to the internet, and like you don't know what's going on in there. You want to protect your engineering network from the IT, but you know what, they're thinking exactly the same thing. You've got 20-year-old machines down there in the OT, and we want to protect our IT system from that. So yeah, it sounds a little bit trivial, but it's not actually a bad way of looking at it.
So maybe train them both as internal auditors for cybersecurity, and they can audit each other.
That's a way. Yeah, why not? I'm sure that'll help them make friends. Yeah, for sure. Yeah.
Any more questions? There we go. Oh, thank you.
So we know that OT devices are known for lasting longer.
Yeah.
Now, as cybersecurity threats and viruses are coming, new viruses are coming in, so maybe PLC manufacturers have to come up with the new firmwares. And what I recall, like when I was doing programming 5-7 years back, so when you need to upgrade the firmware, you have to stop PLCs, upgrade the firmware. And in some industries, the downtime, you don't get that downtime. Like, it might be like a couple of days in 2 years. So how PLC manufacturers are working on that? Because in IT, as you said, like when you had an update on Outlook, you can it doesn't stop your process. But in PLCs, you want to put that firmware, but you understand there will be a challenge because you are stopping all the production.
It's a big challenge, and I think the way to think around it at the moment is coming back to policies and procedures, the way to deal with it is be fully informed about what that patch means, because not every single vulnerability is going to be relevant to your system. It might be published for a particular protocol that actually you're not using, or a particular feature that's turned off. So in that case, you can make a very informed decision, document it all through your risk assessment that I've reviewed this, and although it's a big deal if we are using that protocol, we're not. So we're not going to do any downtime, and we're going to leave it as an accepted vulnerability. In other cases, this is where it becomes a management decision. If it's a very highly rated vulnerability, there's a scoring matrix called CSS scores, CVSS scores of. We're getting into lots of acronyms now, but there's basically a scale of 1 to 10 on how severe vulnerabilities are, and that helps you understand how big of impact it might have. And you might find that if it's a particularly big vulnerability that has a big potential impact on your plant, that downtime, although maybe it wasn't planned, it's a management decision to decide whether it's worth the risk to carry on without it or whether it does need doing. Do you see what I mean? So it's about making informed decisions and not saying, oh, we're going to necessarily throw every patch that comes our way. You need people who understand what the impact is, and maybe that might mean speaking to the manufacturers, but generally the documentation that comes with these vulnerabilities helps you understand exactly what it means. But you as a machine builder, system integrator, those are the kind of questions that end users are going to keep coming to and asking, oh, this vulnerability has been published, do I need to worry about it for my particular machine? That's where you need to step in and help them, and also be the people telling them about the vulnerability in the first place. That's the legal obligation. Yeah.
Can we all agree that Ben is the king of acronyms? Honestly, how many
I'm
you
sorry
have
if
to
it got a bit-
remember?
yeah.
It's amazing. It's brilliant. Ben, thank you.
Right, thank you.
Here we go. Right, okay. So everyone enjoy lunch though? Yeah, good. All right, before we begin, I just want to get a little selfie, because just to do this for social media of everyone. So as many people as possible. Cheers. There we go. That's the joys of social media now. Right, okay, so we're going to welcome on stage Jason Reed from Pilts. Now, Jason is well versed in the current issues manufacturing companies face, likewise many companies like yourselves, and what they need to consider in order to comply with the latest safety legislation and standards. And that's why Jason is perfect to discuss how you can keep your machinery safe in a digital world. So please welcome Jason onto the stage.
Hi. Hi, thank you everybody. My name is Jason Reed. I'm one of the account managers at Pilts Automation. Hopefully you didn't have too much to eat and you're not too sleepy straight after lunch, but there will be some overlap potentially with the presentation that I'm going to do now and what we had prior to lunch with Siemens, but I'll be looking at it from a machinery perspective, really. So, yeah, I'm going to be talking about how we keep machinery safe in an ever-evolving digital world. So the agenda that I'll run through really for the presentation is safety and security, how that goes hand in hand. We'll look at cybersecurity legislation, cybersecurity standards, IT versus OT. We'll look at possible side effects on the safety-related parts of a control system. I'll go through risk assessments and what we mean by zones and conduits. And then I'll talk finally on some countermeasures on how we can try and help really mitigate those risks. So cybersecurity going hand in hand. So security vulnerabilities really enable machinery safety to be manipulated, and typically when we talk about machinery safety, we talk about protecting our staff from hazards from the machinery itself, from the hazards from the machinery itself. When we look at security, we're protecting the machine and the data from manipulation and unauthorised access. So here we're protecting against corruption. And so when we look at security aspects, we can have physical security, which is protecting the machine from personnel. So this could be unauthorised access via access to the machine, and operator errors from doing that when they didn't need to, but also information technology security, and this is protecting the industrial devices such as HMIs, safety PLCs, controllers from attacks. And that could be both remote or in-house at the machine. So cybersecurity legislation, I know we've touched briefly on this, but for machinery safety, we have the Machinery Directive, and this is becoming a regulation in 2027. And at the minute, the directive really, to achieve conformity to that, we look at harmonised standards and norms. But with that becoming a regulation, we still look at that, but we now incorporate security as opposed to just safety. But again, we'll be doing this through harmonised norms and standards. So what are the kind of changes and the transition? So with the machinery regulation, we have to look at protection against corruption. And for security, there's a focus really on functional safety. So the functions of functional safety. So currently there's a standard 13849 Part 1 that was released in 2023, and that talks about requirements for access to functional safe controllers, and it talks about employees and their skill set, and access for qualified personnel only. We have the Network and Information Security, or NIS2, which was spoke about earlier. So the main difference with that as opposed to NIS, NIS was really aimed at kind of like utilities, so like water, gas, critical infrastructure. With NIS2, it also looks at like large employees, more than 500, and turnover as well. And then we have the Cyber Resilience Act, and this is for manufacturers with an obligation for products with a digital element. So everything you see in blue is really security. In yellow we have for safety. So how will that affect us? So an overview really of the important changes with regards to security is the inclusion of what's called emerging digital technologies. So it doesn't mention AI specifically, but we can see that it's referring to that in the machinery regulation. The inclusion of cybersecurity and associated safety requirements. Requirement for human-machine interaction. And then we have requirements for authorization and access rights in relation to the safety and reliability of control systems. So if we look at the additional safety requirements with regards to Annex 3 of the machinery regulation, we have connection of additional equipment must not lead to the loss of a safety function. Remote access devices must not affect safety. Hardware components that are important for connecting and accessing safety-related software must be adequately protected against unintentional and deliberate corruption. The machine must collect evidence of lawful and unlawful tampering with the hardware. Software and data relevant to the safety shall be identified as such and adequately protected against, again, unintentional or intentional corruption. And the machine must collect that evidence, and also the machine must identify the safety-related software installed. And the important things to note here is that it's talking about intentional and unintentional. So we're not talking about necessarily a state-sponsored attack or some teenager in their bedroom trying to hack into your system. It could be a disgruntled employee or just an employee making a mistake on a system. It may be that I saw a colleague of mine clear a blockage on a HMI last week. I now go, the same blockage happens this week. I know what happened. I saw John going into the HMI. I do that, but because I'm not trained, competent, I make an error. That is a breach in essence. So PILT interprets the changes to the regulation to mean that it's mainly about protecting safety via security measures. And as mentioned earlier, from the 20th of January 2027, manufacturers of machinery must confirm that the machinery complies to machinery regulation, which will then also include the security aspects. And this includes protection against falsification and measures to resist malicious attempts by third parties to create hazardous situations. And compliance with machinery regulation is formally confirmed in the Declaration of Conformity, etc. So who do the security changes affect? So if we look, we have this could be our IT manager or blogger, for instance. We have our manufacturers of electrical equipment, we have our machine builders, and we have our critical infrastructure. So manufacturers of electrical equipment typically will supply to machine builders, to supply to infrastructure. Here's our hacker, that potentially there is a threat within each organisation. So NIS2 is an important entity for manufacturers of electrical equipment, but they must conform to the Cyber Resilience Act. Machine builders, NIS2 will be again important for them based on their number of employees, etc. But the machinery regulation is what they'd comply with. And then for critical infrastructure, NIS2 is essential. So standards. So there's kind of two main standards that we would use with regards to cyber security. We have ISO 27000, which is really all about information security management. So it's all organisational policies and procedures, really. And it's all to do with information security management systems. So what would you do if there was a breach? What training do you have in place for your employees? What kind of countermeasures would you have with regards to monitoring or measuring or doing analysis? So it's not hardware, it's all about the management of cybersecurity. Something that was mentioned earlier, 62443, this is a standard that we would use for industrial automation and control systems. And again, you can see here, the way that we've broke this down with the parts, as you can see for factories, suppliers of equipment, and then for components. If we look at machinery compliance, typically this is the kind of process that you would follow. So you would have your machinery compliance and certification, so CE marking. There might be some kind of, if it was international compliance, you might look at ANSI standards for the states, etc. But you typically start with your risk assessment. You may look at safety concepts where you determine your performance or your seal levels. You then do your safety design. So you would do your safety verification to prove your design meets those performance levels. You then do your system implementation. You do your safety validation, and at that point, it normally stops. Yeah, you'd supply the machine, and that would be it. Unless there was an incident in the future, or that an interlock failed, you wouldn't need to do anything to it. Whereas for security, you'd do your security risk assessment. You would then do your security concept, and this is where you'd look at your target security level. Typically, we would use 62443, and then we would use the technical report on how we could implement that, 63074. We then do our safety design. We would then do security verification and tests, but we wouldn't stop at that point. Because it's what was mentioned earlier in the previous presentation, it's ever evolving, because at this point as a manufacturer, if you then knew that there was like a firmware update that was mentioned earlier that might be required for the safety PLC, for instance, then you need to communicate that some way of communicating that, either with your customers, or if you were a user of the machine, then you would need documentation that would typically be provided by the OEM to say that, you know, do checks with your firmware, etc., and this is how you need to implement it. So again, at that point, you would start all over again. So IT versus OT, again, which was touched on earlier really. So we're all, again, familiar with the IT network. Here's our OT network. And you know, what was discussed earlier is that a lot of the machines and the infrastructure within the OT network, because it's legacy equipment and has been there for many, many years, will not be up to date, and so, you know, is vulnerable to security vulnerabilities and breaches. So we'd look at how do we achieve data confidentiality, integrity, and network availability, and this will really change based on your requirements really. So for confidentiality, that's data that may need to be read or modified by authorized users. The integrity, data may not be unknowingly modified. And then we have our availability, which is the prevention of system failures, and that we must guarantee access to data within an agreed timescale. And what you would do is, depending on your requirements, if you're in an IT network, you'd probably find that confidentiality would be the highest, followed by integrity and then availability, because if your printer is broken or your laptop's broken, there's normally another one that you can go and get. Whereas in a manufacturing environment, availability will be crucial, because you can't just go to stores and get another production line. You know, that's got to. So what's the possible side effects really on the safety related parts of a control system if there was a breach? So here we're looking at our security. So if there is a threat and that's succeeded or exploited, then that would lead to a vulnerability of the machine control system. The consequence of that would be on an asset or a component or a human, and that could either be other consequences such as environmental impacts, loss of property, business interruptions, etc., or it could lead to a security risk to the safety control system. Oops. And if it did that, that failure or malfunction of the control system would actually mean that the safety functions or function is no longer performing as it was intended. So that could be that there was a failure in a diagnostics, or it could be reconfiguration. So you might have a light curtain stop performance test. So your machine might stop at, I don't know, after X amount of seconds. That may be increased. That can then lead to degradation of the risk reduction measure. So that could be unintended movement, or it could be an increase of the machine reaction time. And then obviously that could then result in harm. So that's what you're trying to prevent. So how do we try and combat this? So I'll use the analogy really of an airport. So before you go to the airport, when you've booked your ticket online, you're going to get information sent through about what you can and can't take on the airplane or into the airport. This is all really to do with 27000, so it's all the information, really. What is allowed to go in your luggage, what isn't allowed to go in there, for instance. So that's all your information, security policies and procedures. And then there'll be announcements about don't leave your luggage unattended, for instance. Then we have physical security measures, and these are more to do with 62443. And so in this case, you'd have video surveillance, you've got regular police controls, identification and authentication. So if you go to a ticket counter, am I the person to get on the flight? Border Patrol, who am I? Am I allowed to leave or enter the country? And at the boarding gate, am I allowed to board the plane? And so again, if I'm airport staff with a key card, am I allowed to gain access to restricted area, for instance? So if we use that analogy, airports really are segregated into different zones. So in the green zone, we've got our departure lounge. Anybody can go there. And then in the red area, we've got our ticketed area. That's our departure. And then in addition to these zones, we've got our gates for the aircraft. And in order to move between these zones, we have conduits with specific rules that are defined. And so to move between the green to the red area, I need to go through my security checkpoint. And at that point, I need to show my ticket, might be my passport, etc., my boarding card. And what those rules are really are typically rules that you would have with a firewall, for instance, between your IT and your OT network. What does that look like in a industrial automation and control system? So everything in the red area is our industrial automation and control system. On the outside of that is our IT network. And what we're effectively going to do is zone all our hardware together. So we may put all our safety together, for instance. Any kind of industrial automation we may put, all our wireless products we may do, process. So we'll start to group and zone those together. This is in a very basic form. And then we'll look at the zones between them. So how do we communicate between the two? So if we carry out a maintenance command, for instance, what part of the machine and devices do we use within that process? So, we may just go straight to the automation. We might do something with safety, and we'd need to look at the rules and define those rules and processes, like a firewall really, to determine how we can move from each zone. Now we'll talk about countermeasures. So these are what are called the foundational requirements within 62443, and they're kind of broken down into 7 areas. So we have identification, access control, use control, system integration, data confidentiality, restricted data flow, timely response, and resource availability. And when we do our risk assessments, from our risk assessments and through looking at the movement between zones with the conduits, these will effectively allow us to mitigate that risk, really. So if you imagine on a machine and machinery safety, you'd use safeguards such as a fixed guard, or you might use an interlock or a light curtain, for instance, to reduce that risk. We'd use foundational requirements and countermeasures to reduce those risks in cybersecurity. And so we can use safeguarded support systems, and what these will do is they will allow you to identify if a person's authorised. There'll be verification that that authorised person is selected for the task that they need to carry out. Inform the user of the authorised tasks. Enable what we call different modes of machines operations, and specifying the zones to which authorised personnel have access. And what this means is that typically mechanical keys that you see in machine panels that are left in, where you may be in a run mode, a jog mode, inch mode, they will effectively be phased out because you'll have no way of being able to identify and authenticate who is doing what to that machine. And so with a safeguarding support system, you can identify personnel, so in the way that you would with a driving license or a passport, for instance, and then you can allow them access to production equipment. But again, when we mean access, we don't just mean access via a gate or a flap. It could be access to a HMI, safety controller, etc. So it's physical and security aspects. So if we look at different scenarios for customers, you need employee, liability, protection, productivity, data. They're all values that a company will need to protect. And you'll have different people within the organisation that will be responsible for those values. And then within those, you're going to need to protect access. So like I say, to HMIs, doors, safety controllers. How do you change the mode of a machine? So if from a run mode to a jog mode, if you wanted to gain access to a robot cell, for instance. Maintenance safeguarding, so kind of like to prevent unexpected startup, intelligent lotto systems. and then for machinery security with firewalls. And so this is just some hardware that you can use to use that as a countermeasure against the security risk. So to put that into operation, this would be a typical machine. So you've got your mechanical key, you've got your Ethernet and your USB ports, and as it stands, there's no identification, key's always in the panel. You've got direct access to USBs and Ethernet, so you're open to a lot of risks. What you can do with safeguarding support systems is that you can identify yourself by means of a RFID key. You can change the operating mode of the machine, so only if you're trained, authorised and competent can you do that. You've got data protection via the USBs and Ethernet, because unless you've got this key, unless you're authorised, trained and competent, you can't enable these devices. So there was there's a large automotive manufacturer that kind of disabled all their USBs because they were blowing them on production lines. I think Samsung's phones must take slightly more current, and so they were just blowing. Yeah. So that would, so that would prevent that effectively. Direct communication with the PLC and HMI. So again, if your key isn't in place, then you physically can't change any of the parameters, or based on what your skill set is, I may be able to go in and have a look at the program, but that's all I can do. But my supervisor, they can go in and actually change the program. So that, again, that's how you protect yourself. That's a video. Is it going to play? It's coming. Oh. So another example really would be access to a machine. So you might think, well, it's not cyber security, but it is in a way that you need to identify and authenticate who can do what to your machine. So here's a typical palletizing line. But this particular application will have a number of zones. And you only want trained, authorised and competent people to gain access. So, I may have seen somebody go into the machine last week to clear a blockage, but it doesn't mean that was the right thing to do. And so a safeguarding support system really would only allow trained and authorised people to gain access. So in this scenario, you can see that I've got an operator that wants to gain access. They would present their key. And if they were trained, if they were authorised, and if they were competent, then it would allow them then to log into the system. So you could have multiple people logging in, for instance. They would log into the area, they would go inside. So this has now come to a stop, this particular part of the machine, but this is all running. I've got a colleague at the other end. They now wish to gain access to the machine. So again, only if they're trained, authorised and competent can they do that. So they're logging themselves in. But it will now show there's 2 people logged into the area. So they're going to do what they need to do, clear a blockage. Once they've done that, they'll then leave. They'll then log themselves out, but they will go to restart the machine. But they won't be able to restart because there's still somebody else logged in. And then what you don't need to do with this particular system is you don't need to come in and out the same way. So there's a second exit, there's another exit point there. You can actually enter and leave out of any access gate. And now they would put their key in and they would log out. And then they can restart the machine because there's nobody else logged in. And you would keep a record of this at each point as well. So the machine will keep a record of that, of who's doing what. So if somebody did come along and they tried to gain access and they weren't trained and competent and they didn't have authorization to gain access, you could record that somebody's tried to do that as well, and it may be you need to do some retraining, etc. Other countermeasures against threat really, is what I mentioned earlier, is that USB or Ethernet ports, unless you've got the correct key, you can't actually initiate that. So if your PLC, your safety PLC, was locked in a cabinet, you know, only a trained, authorised and competent person would be able to gain access to that safety PLC or controller. And again, you would keep a record of that. And if you wanted to do remote access, then this could be our client. They could be sitting in Spain somewhere. Here's our machine in the UK. You may have all the correct protocols for your VPN and your firewall, but you can't actually gain access to the machine because locally you would have somebody with their key. They would identify or authenticate that you are authorised to gain access. So I'd pick up the phone, okay, John, I know it's you. And then I would put my key in and I would allow that local then access to the machine. So it's like a two-factor authentication, really. So you can see that here. Here's our machine with our security bridge going to our safety PLC, and then we're doing it with a key just to allow that final connection. What I would point out is that a lot of the standards and the regulations that have been mentioned today are all to do with Europe, and with Brexit and the UK being out of Europe, what does that mean? So the likelihood is that the UK, so we now have UKCA marking, which we do to supply machinery safety regulations, which in essence is the same as the machinery directive. It's more than likely that we will just mirror the machinery regulations when it comes out. And because the machinery regulation doesn't really mention NIS and the Cyber Resilience Act, that should mean that we should be able to mirror it, because the UK government has said that they're unlikely to follow suit with the NIS 2 directive. We're likely to bring out our own Cyber Resilience Act bill instead. So, but if you are a machine manufacturer that's supplying to Europe, then obviously you would have to conform to machine regulation anyway, and NIS 2 and the Cyber Resilience Act, because you are supplying into Europe, yeah? Or if you are part of a European national, business, then obviously they'll put that emphasis on you to comply with that regulation and directive. Yep. Thank you. Any questions?
I'm ready with the microphone. Oh, sorry. Ready with the microphone. Any questions? None at all? Yes. Thank you.
So our Cyber Resilience Act, will that make will we be compliant to NIS 2 if you follow that? Is that the plan? So if we have our Cyber Resilience Act, if we as machine builders are compliant to that, will that be set up so that it's complies to NIS 2?
No, so they're different. So NIS 2 and Cyber Resilience Act are two different things.
Yeah.
So the Cyber Resilience Act really is for manufacturers with a digital element. So like PILTs, we will have to comply to the Cyber Resilience Act because we manufacture hardware with a digital element. And what that means is if there was any kind of breach or if we found any vulnerabilities, then we would have to let the marketplace know. With regards to NIS 2, that's really for utilities and large employers and companies with large turnover. So they're kind of two separate things. In the UK, we'll have the Cyber Resilience Bill, I believe it is. So that and this was the previous government. So what they said was that they wanted to do something above and beyond what was in NIS 2.
So the hope is that what we do will be above and beyond NIS 2. So we'll hopefully we'll automatically be compliant.
And you don't necessarily just have to follow 62443 as well, because under the machinery regulation, there's obviously changes to the essential health and safety requirements, which is what you'd have to adhere to as a manufacturer. And so under 1.2.1, that's to do with functional safe controllers. That's being rewritten to how you would comply to that. And then 1.1.9 is corruption. So, and that standard is currently being written at the minute and being fast-tracked, because obviously there's not a lot of time left before you have to comply to the regulation. So I think that is 50742, I think it is, for memory. Yeah, and companies such as Pills, Rockwell and others, they'll be sitting on those committees to try and write those standards, if that helps.
Any more questions? No? Okay, well thank you, Jason.
Okay,
Thank you so
thank you.
much. I'll take your microphone. Thank you. I'll put that one over there. Okay then, so the next speaker on the stage is Grant Coffin. He has over 30 years of driving industrial automation, including 16 at Rockwell Automation, making him a key expert in optimising systems for performance, sustainability and profit. With all of that experience, it was an ideal candidate to come up onto the stage and share his knowledge on sustainability. So please welcome Grant. And just put that on your top.
Small computing glitch there. Welcome to Rockwell. I know you've been here most of the day, but it's a pleasure to host this. And as Lindsay said, I've been in industrial automation now for the best part of 35 years. I started as an apprentice in Michelin in Dundee, and I've been, well, actually 17 years with Rockwell now, and I've had a few jobs within Rockwell. I was what we called a solution architect, where I basically helped customers on digitisation journeys, modernisation journeys, and then moved into the role I'm in today, which we have two business units. We have what we call intelligent devices and our software and control business units. Intelligent devices are kind of everything at the bottom of the wall, yeah, kind of sensors to motion type systems, so device-based things. And then the software and control business unit is our networks controllers and obviously our software portfolio. And I now have a team of people that work for me that kind of do the same thing as I did before, which was that kind of solution consultant type role. When Laurie asked me to do this, talk about sustainability, I'm like, all right, short straw. Yeah. But actually, listening to everybody talking today, I'm probably more at home talking about cyber, talking about safety, in that automation space, because it's where I've been inherently living. But I have been involved in some of the sustainability things that Rockwell are doing from a product point of view of late, because of the role that I perform and the feedback I need to give to the technical teams within Rockwell. And I probably didn't realise that it was all part of a kind of bigger picture. So when I went and started researching what am I going to do, will I talk about energy saving? Will I, talk about emissions and all that kind of stuff that we automatically relate to sustainability? I was like, actually, I'm kind of doing it on a daily basis, yeah. And it actually sums up a lot of what we've been talking about today. And I'm going to use Rockwell as an example, okay? And just in terms of when we talk about sustainability, what we're actually talking about. So I'm going to take you on a journey, right? Hopefully, right? So I'm just going to, as I said, I'm going to talk a little bit about Rockwell and Rockwell sustainability, because what it does is it sets the context, which then poses the question, kind of why? Why are we doing all these things? Where is it coming from? Why all of a sudden have we got EU directives that are coming out, left, right and centre? And I had to laugh at the question there around, what the UK are doing, because we'll do the same, right? But we'll call it something different just so we can be divergent, right? Is kind of what we'll do, right? So why are we doing it? And then a little bit around, once we kind of, why it's all happening, there's a couple of things happening around product and product development that I just wanted to make people aware of, because it is going to impact us. It's going to impact declarations of conformity as we move forward, because we're going to have to start looking at our overall environmental footprint of not just the production of products, but how they're used, the recyclability and disposal at end of use, right? So hopefully I'm going to take you on that journey, and we'll see how we go. I've got some notes here, right? I was conscious of someone saying this morning, there's too many acronyms, right? I've got loads more acronyms, right? So just to make sure I get the wording right, yeah, I might refer to my notes every now and then just to make sure I get the appropriate naming. So Rockwell, right? I haven't done this as a kind of, this is Rockwell, I want to force Rockwell on you. We have to do a sustainability report, and here comes my first acronym, right? So the Corporate Sustainability Reporting Directive, right, the CSRD, as of this year, is a regulatory requirement to operate in the EU. So corporate organisations above a certain revenue that operate in the EU and want to sell product in the EU have to provide a sustainability report. So whilst it's got all the financials and everything else, it's got a load of other stuff that's more on the right-hand side about all the good things that we do for community, all the good things we do around promoting things like STEM and all that good stuff, as well as the environmental aspects that we're trying to do to, improve the products that we use within the products that we make, the raw materials within the products we make, and how we ship that around the world and all that kind of good stuff is all in there. Things like investment in people, yeah, our cultural, the cultural aspects of our organisation. A lot's been mentioned now about the diversity, equality, and inclusion that is happening within the US just now, and whether that's a good thing or a bad thing, yeah, has it gone too far, is all really topical, and is part of what we incorporate within our sustainability report. So what does our sustainability report look like? I'm not going to go into masses of detail, but what I'm trying to do is highlight that when we talk about sustainability, we're not just talking about environmental. We're not just talking about emissions and carbon footprint and all that kind of good stuff. It's a much wider kind of view of how corporate organisations operate within a business environment. So we have our ESG, and you'll hear, everybody has that ESG report. But then on the left-hand side, what are we looking to do? And this is when organisations start talking about, and the things that we're probably more familiar with from a sustainability point of view is people start talking about, the emissions, the scope 1, scope 2, scope 3. Everybody aware of scope 1, scope 2, scope 3? Yeah. So scope 1 are the emissions that we produce, manufacture, and what we manufacture. Scope 2 is what we use or what we purchase to do that, like things like energy and gas and all that kind of stuff. Yeah. Even me coming down here today comes into our scope 2. Yeah. And then scope 3 is much more complicated because that's more around when our product, our finished product, kind of leaves our warehouse, if you like. Yeah, it's the transportation, distribution of the supply chains into the market, how the product is then utilised, how it's recycled, how it's disposed of, all come into scope 3. So much more difficult to kind of measure. And what I did think about when I was looking at this scope 1, scope 2, scope 3, if everybody's doing it, yeah, I'm not quite sure how the measurements work, right, but we're double counting, right? Because if you think about the energy we consume when we're manufacturing a product, we need to declare that. But the energy manufacturers that are manufacturing that energy are also declaring that. Yeah? So it kind of builds up a picture of the whole of our, as a society, as a global society, what our carbon footprint or what our environmental footprint looks like, and the impact that it's having, not just on the environment. We think about wildlife and rainforests and all that kind of stuff, but actually the impact that it's having from a social point of view. Yeah, me and you as individuals. Where does it all come from? Right? Why are we doing all this stuff? So it actually came from all the countries in the world getting together under the UN, yeah, and came up with a resolution that defined 17 goals that they wanted to do under under the sustainable banner. Those are the goals. That's what we're aiming at. Some of them are more aspirational, I would suggest, than others. Yeah. But it's an interesting place to start, right? And as I said, I'm going to take you on a journey, because I went on this journey when Laurie gave me this task. Yeah. So that then filters down into, right, we've got all these 17 goals that the world wants to achieve. So the EU have taken an initiative on developing that further, and actually, you know, as we go through this, we become more and more granular, as you would expect. And you've heard people talking about regulations and directives as we go. Unfortunately, I'm going to talk about some more, right? None of this gets any easier. Yeah. So Europe came up with a European Green Deal. And the Green Deal is an aspiration to be more sustainable as an environment. And actually, the Green Deal talks about decoupling economic growth from environmental impact. Yeah. So basically saying that, you know, we want to grow the economy, but we want to do that in a clean and environmentally friendly way, right? We want to decouple that growth aspiration from what we're doing from an environmental impact and consumption point of view. And to do that, they created the new Circular Economy Action Plan, right? Often known as CEAP, right? So within CEAP, the circularity, and I'll have to just refer to my notes again, just so that I get this right. So its focus is in 6 kind of different areas. And those 6 areas are the redesign of product. So we're using more environmentally friendly raw materials and resources. Manufacturing, so how we make the product. Distribution, how we ship it around, obviously. Use and consumption is the interesting one. Yeah, so how we use and consume that, and then how we potentially reuse that. Yeah, so repurpose. And then the last one is, you know, the recyclability and kind of disposal is kind of wrapped into one, right? So that whole circular economy that they're trying to create, that recyclability of product, and it has a huge impact on how we look at how we design our products now. Yeah. That leads us into, right, and a kind of keystone. So the bit that enables that circular economy piece is this Eco Design for Sustainable Product Regulation, ESPR. I'm sure you've all heard of. It's been talked about quite a bit. What it does is it provides a legislative framework. So it is regulatory in itself, but it provides a framework where a lot of the things that we've been talking about today actually plug into that legislative framework. Yeah, cybersecurity is part of what we need to do from an eco design and sustainability point of view, right? So we talk about design for security. Safety is a key aspect to that, and actually the bit that I never thought of, and it was quite interesting this morning because I don't really get involved in it, but that whole kind of, you know, hygienic piece as well is all part of the design of a product. All feeds into that the legislative framework that brings ESPR together. They're bringing in, and it's not finalised yet, but there's a lot of product-specific measures across different sectors, and there are, what they've done is they've prioritised those sectors. We'll talk about that a little bit later on, but they've prioritised different sectors based upon the environmental impact that those are having just now, and social impact that those are having just now. So there's a whole kind of ream of directives and initiatives and acts that are coming in with guidance to help us kind of navigate what needs to be done and how we need to bring to bring products to market if we want to sell into the EU. So when this started off, it started off really specific in certainly from an electronics point of view, started off really specific, and this is where I started to get involved from a Rockwell perspective, because electronic components form part of the scope of the product regulation. But it's gone significantly, you know, there has been a scope extension, because the products that it now refers to have gone way outside and cover pretty much every sector that of marketable product that goes across the EU. Everything from, you know, everything from clothing right through to, you know, what we're doing from a you know, from an environmental or vehicle perspective, aircraft and all the rest. So there's a load of new requirements come into that, yeah. And you know, for us, and some of this is Rockwell kind of specific, if you like, because it's things that I've been working on. So I'm not going to talk about what we need to do from a clothing point of view. It's not particularly pertinent to the room either, so I thought I'd avoid that. But talking about the electronic pieces and what we need to do from a product perspective. So these are the aspects that are under consideration at the moment, that are included within product design. So you can see all the blue things are what we need to do from a kind of raw material and a resources point of view. These are all the things that are being looked at and evaluated and measured in terms of the declarations that we as manufacturers have to make. We then also have to look at, you know, what is the reusability, recyclability, as well as reliability, and what we mean by that is the life cycle. Yeah. So somebody talked, I think it might have been Ben, was talking about life cycle earlier on today when he was talking about the kind of product evolution that we have within the electronics environment, right? IT, I think you said, was a 3 to 4, maybe 5 year re-roll. You know, in the industrial world, we expect things to last, you know, 20 years. You know, I'm still talking to customers that have got PLC 5, if anybody's familiar with Rockwell stuff, PLC 5 that goes, you know, back to the 1970s. Yeah. So that life cycle now, we've got a contradiction in that we've got lots of things happening with, you know, the evolution of compute technology, the evolution of AI is accelerating the development of products, you know, beyond belief, right? Faster than we ever thought we could. Well, it kind of goes in contradiction to actually what does that life cycle of a product look like? If you look at the life cycle of a product, it's actually getting shorter rather than getting longer. Yeah. So how do we square the circle? And that's what this legislation is trying to do a little bit. And then, you know, at the end, the recyclability, recovery of material for reuse, and then you know, you have the supplemental waste that kind of goes alongside that. So those are the things that we're kind of the European Commission are looking at in terms of, and the working groups are looking at in terms of how we define a product. Yeah, and everybody's going, where is this going, right? Because that's where I was. Where is this going? Yeah. So that's really just a summary of the topics that I covered earlier on. Yeah. Those are I guess the key extractions from what the ESPR is looking to try and do. So what? Kind of quick summary of that. And then it's how, right? So we then start introducing a new acronym, DPP, yeah? This digital product passport. And the digital product passport is going to be as relevant for clothing as it is for aircraft. Yeah? All sectors will have to apply. Comply. There are, it's a staged approach, so not everything has to be adopted. So the ESPR was actually adopted and put into law on the 20th of March last year. Yeah. So the timelines in terms of the different priorities are starting to be implemented now. There's lots of different working groups working on different sectors, and those are staged over between kind of 2025 implementation to roughly 28, 29 type time scale. And I'll cover a little bit of that at the end. I'll just give you a quick summary of what we're looking at again, I've only looked at really what Rockwell are doing from a compliance point of view, just to give you an idea of the timelines that we're looking at from an electronics perspective. But the idea behind the how is, so what the DPP is trying to, or will do, what they're doing is creating a product registry, yeah, and this is where it all becomes really complex, because how many products do we consume in the EU, yeah, or across Europe and the UK, yeah? It's massive, right? How do you start detailing and quantifying the data requirement for a registry for the circularity project for all those kind of product details? How do you get that all into a product registry that kind of makes sense and people can search? It's a massive task, right? Because it's all going to have to be searchable on a web portal, because the idea behind it is it's to give us as consumers the information we need to make environmentally sensitive decisions. We will start, the idea will be that we start to select product based on its environmental footprint. Yeah? Now, there could be economics involved in that as well. There's a question from a commercial point of view, do we make products that are more environmentally, let's say, compliant as a term, yeah, to those that maybe aren't, yeah? Do they come with a commercial penalty? Again, all questions that need to be answered, right? But the idea behind the registry is that you'll have unique identifiers. It will have API capability to be interfaceable with different systems. What was the other bit I was going to highlight? There was another bit I was going to highlight there. That was maybe on the next slide. So it's going to have, so it's all going to be QR based, yeah, in a single. So the content of the data that's held will actually be a federated system. So that if you're looking for a Rockwell product from a DPP perspective, you will be routed to a Rockwell server, right? And that's the idea, and that's how the registry will be built. Yeah. So it won't be the European Union or anybody within that holds a central environment. What they'll do is almost pass you through, if you like, to the manufacturer, who has an obligation to have the registry stored. Yeah. But that becomes, again, from a technical point of view, becomes really complex from a multi-product system point of view. If you're putting lots of product together in a single space, that's a lot of data and a lot of information that you need to pull together from a disparate portal point of view. So the idea is try and pull that all together, have that data repository so that people can refer to it and make decisions, and also be able to document. If you're selling machines on, there'll be a requirement for you to document the environmental footprint of the machine you make, plus all the devices that sit within that machine. Yeah. So yeah, sorry to be the bearer of bad news, like. There's another part that comes into the ESPR kind of piece, and this is substances of concern. Already the EU have banned a lot of substances. I'm trying to remember the one now. I was thinking of the stuff that we put in, or we used to put in, HMIs, which is now, it's a chemical used to sit at the back of the screen, is now banned, right? We can't use that anymore. So everybody that makes an HMI has stopped using that within the product. And there's more and more of these coming out, yeah, and there are significant kind of areas that they focus on as well within that, yeah, around not just the environmental impact, but obviously the health impact as well, yeah. So they're looking at things like carcinogens and that type of thing, and the impact that it has, and having to classify all those in terms of its usage, in terms of its incorporation into the product, its usage, its recyclability, And again, the disposal part is a really big part. And we as manufacturers are, you know, or it certainly looks like we as manufacturers are going to have to be responsible for that kind of disposal part at the end. So for anything that's left, if you like, in terms of waste product that can't be recycled, the manufacturer is going to have a method of disposal for that. They might not be responsible for the cost of the disposal, but they have to, you know, they have to declare what that disposal looks like. Yeah. So there's lots and lots of detail when you start digging into what the ESPR means, yeah, what it means from a digital passport point of view, what it means from a substances of concern point of view, and what you can incorporate within your machine design and how it's utilised, and then all the documentation that needs to follow that. So, yeah, I think in terms of the timescales, I think they're a little ambitious, let's say, with the amount of work that needs to be done. You know, this year's focus, to jump back to clothing, you know, that's one of the biggest areas of waste disposal and impact, and you know, they talk about products being produced that are never sold, yeah, and then there's no recycling, they're just disposed of. Clothing is one of the worst areas and is a key, that's one of their high priority areas. But if I look at what's been asked of us as manufacturers, and again, I'll just have to refer to notes, and this is indicative of an indicative timeline. So the ones that affect Rockwell directly, motors and variable speed drives, we're talking around 2028, indicative, to have the digital passport and the registry all complete. Industrial fans and associated electronic control is 2026. Power supplies is 2026. My eyesight's getting worse. 2026. Transformers is 2027. Yeah, I thought that was quite interesting given what had happened at Heathrow. Computers and computers also include, you know, what we would class as a controller because it has a CPU. Is 2026. Light sources and control gear is 2028. It's extremely large task, and electronic displays is also 2028 indicative. Yeah. So when they come into law, that's when we as manufacturers have to ensure we comply, and we're on track to be ahead of that. I know other manufacturers are on that kind of road as well. We have some things with the digital footprint already declared, or the digital passport already declared. We have some on the way, so we're well ahead of achieving that. But that's when, you know, you as consumers of that product or passing it on to your customers will have to start documenting that as well. So there's a significant body of work that needs to be done to comply with the demands of ESPR. And this is where, you know, going back I guess back round to where we started, where we were talking about UK compliance and what does it mean for us because we're no longer part of the EU. Yeah, if we were to diverge from this, yeah, that's going to be really painful, right? So I don't think we will. Yeah. We'll call it something else, but we'll be aligned, right? Yeah. All right, that's me.
It's not over yet, Grant. It's
Oh,
not over
is it not?
yet.
Oh, can I not back away? I need to keep my acronyms out yet.
Yes. Any questions? It might be over. I don't know. Yeah, we've got one. Fine. Oh, okay, we'll go with yourself first.
I was going to ask a question on behalf of the machine builders in the audience, and when we've discussed this within my team, who are sellers into the OEM space, we've recognised that many, if not all of our customers and potential customers have little or no awareness of the new legislation, but also, if they are aware of it, what their responsibilities are. Could you give us some clarity quite specifically what the expectations will be on machine builders?
Yeah, so I think at the moment anyway, there. So there's a couple of things there as well, right? So there are some defined things within ESPR, within the CAP around what a product is and what it isn't. Yeah. So some of the definitions may be so some of your machines may be classed as a product. Some of your machines may be classed as, you know, specialist machinery, one-off type things, right? And the compliance looks different for both. The compliance for specialist machines looks to be a declaration of conformity, so the environmental footprint will be made up of the components of that machine, whatever that may be. And that could include, you know, we talked about stainless steel and the like earlier on, would potentially be declarations of that, right? So, you know, how much energy was used in the manufacture of the stainless steel that you consume manufacturing a piece of machinery, but then also, you know, within that scope, you'd have to also include your energy input in forming and making that machine as well, right? So that would go to the specialist machinery. Where it's specific product machinery, you'll find that there's a horizontal and vertical aspect to the ESPR. So one is the vertical one is very specific around certain types of product. So I talked about clothing, so that's a real vertical, right? It doesn't differentiate clothing in any way. It's clothing as a horizontal, whereas as a vertical. Got my horizontals and my verticals mixed up. As a vertical, but there's some horizontal legislation in there that covers generic types of product, yeah, or and certain machines may fall into that. So I'm thinking things like mass-produced, you know, lab machines or autoclaves or things like that may be incorporated within that product piece because it's a single entity. It doesn't change much over time. That type of thing. So there will be a difference between the two. Does that answer your question? Does that? Yeah. Well, it was your question, not theirs.
I'm hoping that was a yes. So yeah, we'll move on.
Thank you.
No problem.
So this the DPP is a European project. So I mean, we sell stuff that dangles on the end of a cable at the end of the day, mainly from Europe, but we've also got Taiwanese, Chinese, Japanese. What happens to the machine builder then when they're trying to put something together? Or is there another standard that's been adopted for the rest of the world?
Sorry, what do you mean by putting things together?
Well, so you're talking about on a machine build, and obviously you've got to report on what the sustainability, if you like, of the components on it. That's fine if what's happening if it's products that are supplied from outside of Europe?
So if it doesn't have a digital, if it doesn't have a digital passport and falls into the categories, you'll not be able to use that product.
Okay, that's what I want to do. I'll drop the mic.
To what extent do you think this legislation will help us with re-onshoring supply chains and making supply chains shorter so that you make where you sell where you make?
That's a good question. So, how do you answer that? So I think you know there are lots of issues just now which I think are being obfuscated. I'm going to get political now. I better watch what I say. So I'll take what's happening in my homeland just now as an example. So we're about to demolish the only refinery in the north of the UK. I'm going to get political. This is bad. And we're replacing it with an LNG port so that we can import the gas that we need, right? And we're shipping that from all over the world into that port, right? To offload the carbon footprint that the government can claim, right? And I think if we want to do the right thing from an environmental, I'm talking, this is me personally now, right? This is not a Rockwell view, right? I'm going to state that right now. All right. If this legislation and what the UN are aspirational about, if we want that to be worth something, we need to stop doing that type of thing, and we need to get to where, what you were talking about there. We need to start reshoring, make local, use local, all that kind of good stuff. In reality, the practicalities of that will depend on government policy. And I don't want to make a comment on how good our government are doing. Does that answer your question? I tried.
I think it's a debate lots of people are going to have.
It has to be had. It has to be. And this might be the start of it. Yeah.
Any more questions? I think you might need to lie down. I don't know. Have you got one? Yeah.
So, from my understanding of what you just said about the Scope 3.
Scope 3, yeah.
Yeah, so that was post-sale, how your product's being used.
No, it's not. It's post-manufacture.
Post-manufacture, pardon me. Yes. Leading on question, maybe it's Scope 4. What about sort of post-scale and removal and then maybe repurpose?
So that's a major part of it, yeah. So you've seen in that in the SEAP piece, yeah, that's where they talk about being able to repurpose, reuse or repurpose either the whole of or parts of. And then there's a whole piece after that around the recyclability of anything that's left. And the bit that you're left with, that residual waste, is the bit that needs to, we need to declare, i.e. this, whatever it is, this is not recyclable. We must provide a method of disposal of that residual waste and what you need to do with it, yeah.
So is that in turn, I mean, this might not be something that you're aware of, but is that in turn led to a rethink of the raw materials that you use? So if you think of it as a cycle, going back to the start again, say, once this product, whatever it is been upgraded or removed, and we're left with X, Y, and Z that can't be repurposed or recycled, can we then look back to the start at the next products that we roll out, that we manufacture, that we sell, that we deploy, once they're, and ironically we talked about, like you said, about the PLCs for the 1970s, obviously they've got a long shelf life and long durability, but when we're talking about new projects and greenfield projects, everyone wants to come in with the most up-to-date and well thought out products, because then they can incorporate cybersecurity that yourself and Ben talked about, and the adaptability. But is there a Rockwell sort of initiative to rethink?
Yeah, so it was an interesting, when I started looking at the Circular Economy Action Plan, the thing that struck me was the first thing on it is redesign, right? And I was like, why is redesign? Why is it not design, right? Why is it saying redesign? And it took a little while to click, right? But that redesign it's an evolution, right? It will continue to happen, and as we get, we talked about AI earlier on, as we, that will accelerate our ability to produce more recyclable materials, for sure, right? On the other side of that, we've also got you've got a yin and yang for everything. It will also accelerate the compute power that we're capable of producing, and as we do that, that'll accelerate the redundancy, if you like, the obsolescence of older technology. Yeah, so there is a balance there of, how do you, I think I said earlier on, how do you square that circle, right? That's going to be a challenge for everyone. But yeah, so we're and have been for the last few years, we have what we call a life cycle assessment. So when we start looking at, we're doing it for existing technologies, but when we start looking at the design of new technologies or the next generation of technologies, that life cycle assessment plan is put in place, and we look at the raw materials that we're using, the components that the electronic components that we're using to incorporate the recyclability of that supply chain. Yeah, so it's not just what we're consuming, it's what they're doing as a supply chain. Yeah, and then also looking at, you know, what if that product or those components can be recycled in the future or repurposed. Yeah, what kind of uses can they be put to is all part of that life cycle assessment. Does that? Yeah.
Thank
you. Okay, any more questions? Thank you. No? Okay, well, thank you. Thank you so much.
Thank you.
Okay, so that concludes the section of the speakers. In a few moments, I'm just going to get Laurie to come up on stage, the CTO, just to do a bit of his final remarks. However, what we'd like to do is after this, then we're going to clear away all of the chairs, and then, Laurie, you're going to come up and... sorry, I'll do that again. We'll clear away all the chairs. If you go outside, we're going to sort the whole room out, and then you can come back into the room. But Laurie, if you want to come up on stage, can you use that mic, please?
Yep, thanks. Thank you to all our presenters. So, if I get it all right, Greg, Ben, Grant and Jason. So, thank you very so much. As we've just said, Lindsay just said, we're not quite finished yet. So if you will go and grab a cup of coffee, and then please come back, because all the presenters will have their own tables with some of their products, and you can come back and chat with them and ask them any questions you haven't been able to ask so far. We will be sending out some feedback, so please fill it in. Let us know what you think of today. Let us know what you'd like in the future. We will be running more of these, whether it's the end of this year or the beginning of the next year, we don't know yet. We'll see basically on what you guys say. Finding out on some of the further topics you think you'd like to know would be excellent. And just finally, hopefully you'll all sleep better tonight, knowing some things that you didn't know earlier on today. So thank you again. Go and get a cup of coffee and come back in. Thank you.